टेस्ट बोल दे।
चेक चेक चेक। एमएफ को दिख जाए स्ट्रीम, मजा आ जाएगा।
मजा क्यों आ जाएगा?
अरे फिर वो पूछेगा ना, अरे गमी।
चल रहा है रियल लाइफ। ओके। Custom properties. So just a quick recap. We are doing this Learn OpenUSD certification. It has 8 modules. We have covered the first 3. We are doing the fourth module right now. And then that fourth module consists of Beyond the Basics of Composition. And currently, we did primvars and value resolution yesterday, and now we are going to be doing custom properties. So, yeah, we can get started if you don't want to add anything else.
All right. Let's get going. What are custom properties? So now let's explore the concept of custom properties and universal scene description. Understanding custom properties is essential for tailoring OpenUSD assets and workflows to specific needs, enabling more flexible and detailed scene descriptions. Custom properties in OpenUSD are user-defined properties that can be added to prims to store additional data. Unlike schema attributes, which are predefined and standardized, custom attributes allows user to extend the functionality of OpenUSD suite to their specific requirements. How does it work? Custom schema versus custom properties. Schemas are a more advanced topic that we will cover in future lessons. But let's compare the two briefly. When considering custom properties versus custom schemas, the main strengths of custom properties are their ease of use and ability to define at any time. The main strengths of custom schemas are their ability to group related information and provide standardization. For instance, consider we are creating a web page for ordering a cake. One approach would be to create a single large scrollable text field that we can assign a label to, like what kind of cake do you need, and let the user enter whatever they want in it. Okay, so it's a single large scrollable text field that we can
Bro,
assign.
it means like creating a web page and just giving the text box for to the user and letting him define the kind of cake he wants. And then in the second case, another approach might be to create a form of multiple fields, each of which is designed to store a specific piece of information: what kind of cake, what kind of what type of icing, what size, if they want sprinkles, what should be written on top. So all of this data is like separate fields that can be inputted by the user, and over here there just is like one text field where the user can enter the description of the kind of cake he wants or she wants. Um, so the first approach, the single text field, is similar to custom properties. So the single text field approach is similar to custom properties. It allows the user to decide the information they want to enter. Okay, it's also easier if you're new to working with USD or need to implement custom fields very quickly. This might be the way to go. On the other hand, custom schemas allow us to define a group of data in a more standardized way. However, it requires more planning and consideration. What fields we collect are predefined and it takes longer to implement. With that, let's go back to our lesson on custom properties. Okay, so I understood what this means. All of this. You got it?
Mm-hmm.
You got it right.
Yeah, yeah. On the other hand, let's get back to custom properties.
Okay. Custom properties are created and managed using USD API. They can work just like schema, attribute, and relationships. USD API. Custom properties are also created by USD API. They can work just like schema attributes and relationships. Custom attributes are more common because they can hold various types of data such as numeric values, strings, or arrays and can be sampled over time. This flexibility makes them useful for a wide range of applications, from simple metadata storage to complex animations. Here are few ways we can use custom properties to enhance our OpenUSD workflows. Metadata storage, storing additional information about a prim such as author names, creation dates, okay, metadata. Okay. So custom properties are used to store metadata. And then animation data, defining a custom animation curves or parameters that are not covered by standard schema properties. Oh, okay. Simulation parameters, storing parameters for physics simulations or other procedural generation. Oh, process. This is important. Simulation parameters. Arbitrary end user data because they can be easily defined at runtime. Custom properties are the best way to allow end users to define arbitrary custom data. Custom properties are the easiest and most flexible way to adapt OpenUSD to specific workflows and requirements, making it a powerful tool for industries like manufacturing, product design, architecture, and engineering. Wherever we have multiple data types from many sources with varying purposes, like connecting our OpenUSD to sensor data or IoT for live connected digital twins, or creating production model with attributes like part numbers, manufacturers, life cycle costs, and even carbon data that can sync 3D scene description to 2D project documents like bill of materials of carbon emit. This is important, but I didn't understand this.
Which part?
The last paragraph that I read.
Custom properties are easiest and most flexible way to adapt OpenUSD to specific workflow and requirements, making it a powerful tool for industries like manufacturing, product design, architecture, and engineering. Wherever we have multiple data types for many sources with varying purposes, like connecting our OpenUSD to sensor data or IoT for live connected digital twins, or creating a production model with attributes like part numbers, manufacturer, life cycle cost, and even carbon data. Yeah, how are we going to connect our OpenUSD to sensor data?
That is later, bro. I think
Yeah.
that will come later. Look at this. Based on custom properties, listen, you're reading this passage explains that custom properties allow you to attach any kind of real world business data like tracking numbers, costs, or live sensor feeds directly onto a 3D object, transforming a basic 3D model into an intelligent digital. Oh, so basically, it's saying when we are going to create our 3D, the digital twin for
Mm-hmm.
simulation, the data for the object that is in the digital twin will be will come from these real world business data like tracking number, costs, or live sensor feeds.
Mm-hmm.
So here's an explanation using the simple analogy. The magical shipping container. Imagine you run a global logistics company and you have a standard 3D digital model of a shipping container. Without custom properties, standard 3D, the model only knows basic 3D data, how tall it is, shape, color, looks like shipping container, but it's completely blank on the inside. With custom properties that are sticky notes or something like that, they're like an infinite supply of magical invisible sticky notes that you can slap onto the container because they are completely flexible. Different departments can stick their own custom data fields onto exact same 3D box. Manufacturing and business teams slaps on notes like part number CNTR, blah blah blah, manufacturer steel corp, life cycle cost 5,000. Oh, okay. The environmental stability, sustainability team adds a note carbon footprint, blah blah blah. Because this note is digital, it automatically syncs up with the 2D spreadsheet on your desk, the bill of materials or a carbon calculator. Oh, the IoT and engineering team hooks up a live digital wire to a node called live sensor, internal temperature. Now, as the real container travels across the ocean, its actual hardware sensors beam live data directly onto the 3D model. What? The 3D container turns red if the real world cargo gets too hot or digital twin. Oh,
Oh, I get it. I get it. How is
yeah.
it gonna render now?
What?
Now I understood like how we can render OpenUSD scene in real time. So like, let's say we are simulating an environment,
Mm-hmm.
uh, similar to like in AutoCAD we do, or in any
Mm-hmm.
physics simulation engine, and
That is
we
not
would.
related to what I was reading here, right?
Yeah, but like, that is the analogy over here. Like that is how you can relate it. I know that that's not.
Oh, so OpenUSD doesn't force you to only talk about 3D shapes, custom properties, lets you treat 3D objects like digital core track, where industry, whether it's architecture, manufacturing, or robotics, can hang their own unique or real world data tracking systems right onto the geometry. Since you're looking at how custom properties bridge the gap between 3D scenes and external data, would you like to see how format these custom scenes nodes using namespace prefixes to keep your team's data organized? Blah, that's useless. Yeah, what were you saying? How
So I was
how?
saying that like, if we want to relate it in real analogy world, for
Mm-hmm,
example, if we take a simulation engine, right, the thing that simulates everything, and in the simulation engine over here is going to be OpenUSD, and we have already created our scenes and everything, right? So, and we're trying to simulate a box or a box, and we're trying to take an object in that environment. So let's say the temperature of the box is like minus 50 degrees Celsius initially. So
mm-hmm,
we can annotate it with or annotate or label it with a color that is dark blue. And as the temperature rises, let's say, and over here the temperature would be the attribute
mm-hmm,
or the custom attribute that you're gonna create.
mm-hmm,
So, for example, if the attribute value for the temperature is minus 60 degree Fahrenheit
mm-hmm,
or
mm-hmm,
Kelvin or something, minus 60 Kelvin won't exist. So let's say 0 Kelvin, then the color of the object would be something else,
mm-hmm,
right? And now if the temperature scale or the attribute is like 273,
mm-hmm,
then the color of the object that it's gonna show will be red.
mm-hmm,
Now we can basically create a live connection with, maybe, let's say a SpaceX rocket is landing somewhere.
mm-hmm, mm-hmm,
You want to track the telemetry and temperature and everything. So the SpaceX IoT sensors are going to transmit the data over Starlink to you directly.
mm-hmm,
We can simulate the same in our OpenUSD environment
mm-hmm,
eventually. So that's what the analogy over here says based on my understanding.
mm-hmm. Okay. We often recommend custom properties instead of metadata or custom data metadata for prototyping because the former requires plugin based schema development, which is less portable, and the latter is more costly for composition because it is a composable dictionary data type. Grouping related properties. Namespace prefixes provide a way to logically group related properties together on a single prim. This is especially useful when working with data from other sources that have compound. What namespace prefixes provide a way to logically group this provide a way to logically group related properties together on a single prim. This is especially useful when working with data from other sources that have compound or structured types like structs, records, or grouped fields. Since USD doesn't have a native struct type, namespace prefix attributes serve as the standard convention for representing the kind of group data You can even use nested namespace to create a hierarchical organization. For example, sensor readings from an IoT device might be organized as ACME sensor temperature, ACME sensor humidity, and ACME sensor pressure here. ACME identifies their organization and sensor groups the related properties. The combined prefix makes it clear both where the data originated and these attributes belong together conceptually. Okay, this approach is particularly valuable in data exchange workflows where you need to map complex data models from other formats into OpenUSD. Okay. Mm-hmm. Got it.
That was
Working with
pretty
Python.
straightforward. That was not that complex
Yeah.
since Gemini already gave us an example, and I also explained it in a similar
Yeah.
kind of manner. Let's take a look at the code. What does the code says over here?
Oh, they have not given us the comments over here this time.
But I think it would be pretty easier for us to understand it.
Here's an
And
example where we are creating a custom attribute to add a serial number and a last maintenance date to a prim. So a supervisor can easily identify which machines are due for maintenance from the 3D model. Stage is usd.stage.create in memory. Prim is equal to stage.define prim. Example prim xform. Yes. Serial number attribute prim.create attribute. Okay, so this is creating an attribute. My namespace and serial number, SDF type, value type names, string, custom is true. Okay. What is exactly this doing?
creates so it's pretty simple over here. We
I know
start.
this is like some sort of path thing, right?
No. That's not a bad thing. That is basically defining what type of value type or will it have. So it's more related to data type. Remember we have to define the data type.
Type name is string. Okay.
Yeah. So that is what it is saying over there. And then custom. So since it's going to be a custom attribute, we need to define it as true. Assert serial num attribute is custom. Oh, it's gonna verify if is it gonna be that or not, and then again we create and then we set and then we set. Yeah, that's simple. So for custom attributes that are not a part of any schema, we use create attribute method. Dude, it's saying right over there. Like if you go down over here for
Yeah,
yeah,
I know. Let's
yeah.
see the code first.
Okay.
Okay, assert serial number attribute is custom. So what is
Okay.
this doing? I think this
This is
is
a boolean check if whether
uh,
this serial number attribute is a custom attribute or what,
mhm.
right?
Okay. And then mtc date attribute equals to prim dot create attribute. My namespace, maintenance date, SDF value type name, string. So same thing is happening over here as well. So serial number attribute and maintenance date attribute. So serial number attribute set this and maintenance set this. Okay. Serial number. Oh, this is easy. They're just printing the.
Yeah. Like that's pretty simple. Like if you also go through the next four lines, you
Okay.
will get to know
For
what.
custom attributes that are not part of any schema, we use USD prim create attribute method. Value type names represent an attributes type. These are defined in SDF, and more types can be found in OpenUSD's documentation. Uh, for custom attribute that are not part of any schema, we use USD. What is this? Do you know what
Let
this is?
Which part? The SGF documentation are you looking at?
No, no, no. This is the USD create attribute thing.
Yeah, that's
Yeah.
that's the library. Like, how do we create the attribute, and what are the parameters that create attribute takes? Name, type name, custom, variability, and all those things. I think we will get to know more about it as we go deeper.
Okay, and
And
then value type names represent an attribute type. These are defined in SDF, and more types can be found in OpenUSDs. Okay, these are defined in SDF. SDF was this, right? I don't remember SDF.
SGF is the library. Wait, what was the full
Bro,
form? Scene description. Scene description. What is
foundation
that?
or something.
No, no,
Framework,
it's
framework, framework.
framework. Yes, scene
Uh,
description. No, no, is it scene description?
it's not
SDF.
seen. Array, bro, we did this and we forgot
Wait, wait, wait.
SDF.
I'm gonna take a look right over here. Give me a minute. Give me. Come on, come on, come on. Scene description foundations. Foundations. It's scene description foundations. Oh fuck you. Fuck Gemini. It's
What is
foundation.
standing deposit facility? Layer data format.
Scene description foundations.
Yeah. It is the foundation module that handles the reading, writing, and in-memory representation of raw scene description layers. SDF layer represents an individual USD, USDA, or USDC file in memory. Low-level API access raw opinions. SDF path, highly optimized class to reference specific frames or properties within the scene hierarchy. Think of an individual transparent sheet used in 2D animation while the USD level is the final stacked image the audience sees. Here is the clear example of how they work together to create a 3D scene. The scenario is building a virtual room. Imagine you are building a blah 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 layer B A B C is def level isolated cheat has no idea blah blah blah. Um, where is SDF dot layer? Okay, open just the furniture layer. Okay, so SDF dot layer find or open, and then okay, got it. So lastly, setting custom equal to true has no impact on the way OpenUSD treats the attribute, but it is useful piece of metadata to inform end users and developers uh, that a particular attribute is not part of an existing schema. Hmm. Okay, so custom equal to true is just a flag that we are adding so that we let the metadata, like add the information in the metadata to inform end users and developers that particular attribute is not part of an existing schema. Lastly, notice my namespace prefix on the attribute. It's good practice to namespace custom data. So it's good practice, but it's not necessary.
Yeah, but it's a good practice, so we have to anyways follow.
Properties and schemas created by our own organization. Ah, this helps avoid name clashes and it helps the ecosystem understand where content originated from. For NVIDIA custom properties, we use the Omni namespace, for example. You can run these examples locally as Jupyter notebooks. see how to run notebooks locally for setup
Bro, that's the
instructions.
same thing. Why am I reading random shit over there? Just move on to the example one.
Zoned out. My bad. Okay. Custom attributes in OpenUSD are used to define additional user-specific properties for an object within a 3D scene. These attributes extend beyond the standard attributes like position, rotation, color, allowing creators to add unique data relevant to their specific needs. Let me see how many viewers we got today. The fuck, zero views. Zero viewers. I think it's Friday night. That's why. Oh, okay. Let me open the notebook. What is this? Custom properties. Okay. Read it, bro. Read the code.
Again, as we can see, we have created the file path, and then we are going to load the file into a stage. Moving on line 6, we are going to create an xform named world xform, where we are going to load our stage with the world prim. Moving on to line 7, we are going to load geometry xform, and we are going to add world xform with a new path that is going to be packages. So
Mm-hmm.
now the geometry X form looks like we are loading the box package or something.
Mm-hmm.
Now moving on to the line 9, we have box X form. Over here we are gonna append the geometry X form with the another path that is gonna be box prim. And once we have that, then we are gonna convert it into a prim using the X form API by loading the prim over there, and
We
then
are gonna create the box prim
yeah.
by using the usd.prim equal to box xform dot get prim.
Over here, USD.prim is just an identifier. It's not necessarily that anyone has to do it, but for
Mm-hmm.
standard practice purposes, you can define it. You cannot define it. It depends upon the user
Yeah.
completely. So the main part over here is the box underscore xform dot get prim.
Mm-hmm.
Once we have that, and on line 11 we have box prim dot get references dot add reference. So we are going to add our reference, that is our another file. I think this is the file that we have used earlier as well
Yeah. The one that we
for
preload in
referencing.
the asset
Yeah.
folder
So now
and
we have referenced another file onto this box prim. Now once we did that, now we are going to create three attributes, as we can see. So the first attribute that we are going to create is going to be weight. That is going to be acme weight. And then since it's gonna be a float value, so we are gonna use SDF
dot value
library
type
dot
names
value
dot
library
float
dot float, and since it's a custom
custom equal to
attribute,
true.
we are gonna make
Yeah.
it true. And similarly for category, but for category it's gonna be string, so we're gonna define it as string. And for hazard, it's gonna be, I think, bool. Yes, it's bool. So
Yeah.
it's gonna be either true or false. Now we have created three custom attributes, that is Acme weight, Acme category, and Acme hazardous material over here. Moving on to line 9. Now we are gonna use, I think, uh, a new API that is going to be set documentation to define what, like, I think this is going to be the metadata for that attribute. Basically,
Yeah.
what does that attribute mean,
Yeah.
or and what does that attribute signifies. So it says that this is going to be the weight of the package in kilograms for the user, so that the user can understand what
Mm-hmm.
it is trying, what kind of custom attribute the person is dealing with. Then we are setting the category, same for the category, that is the shopping category for
Mm-hmm.
products this package contains, and whether this package contains hazard materials.
Mm-hmm.
Now moving
Hazardous.
on line 24, we are gonna set the values that for the
Of these
attributes that
metadata, yeah.
gonna be 5.5 cosmetics and false,
False. And then
and then
save.
we're gonna save it. So once we save it, this is gonna be the output that we see. It's a typical Amazon box with some kind of barcode label over
No,
here.
this is just the output because we are referencing this file over here.
Oh yeah, yeah, yeah,
The
yeah.
cube
But but
box
but, but this
A02.
but this but this box has some kind of attribute, and that attribute is gonna be the weight of the package, the what
Yeah.
this package
This
contains,
this is the main output that
and
we
the
get.
category. So so if we load this package somewhere in a custom scene or in anywhere on the stage,
Hmm.
the person who is trying to render it will know that what this package is, and this would be
But
really helpful.
if I just run this USDA file, it won't work because we'll need this USDA file as well.
Yes, yes. So we need to make sure
Uh,
to reference the file, otherwise we won't
yeah.
be able to load this uh, box. It will load something, but it won't load the box, like it
Hmm.
won't render it. We will have some kind of reference, or we will definitely have a custom attribute set for the
Hmm.
prim box, but the thing that we're rendering over here, this is from a
Hmm.
reference file that we have created, or the NVIDIA OpenUSD learn OpenUSD kit gives
This
us.
one. This
Yes.
one. Let me run this. Assets cube box A02. This one. This has like a complete folder of. So this we cannot load because it's a USD file, but yeah. So this has all the things over here. You see,
Yeah.
roughness, textures. Yeah. All right. And then we'll just run this one as well. This one. All right. Example two. So this was pretty straightforward.
Yeah, I think the examples are pretty straightforward since we are so much familiar with the code base now.
Yeah. Yeah.
Okay.
It's getting easier, but yeah, some topics are
Confusing, but
comparatively confusing
it's not
and
that hard. Like it takes a while, but we have AI to help us out.
uh,
Okay, now we have okay. What is example two? Example two is modifying the custom attributes. After creating an attribute, we can set and get the value of attributes similar to what we did in the previous example. And over here, as we can see on line 7 to line 10, we are gonna get the attribute acme weight, and then once we have the weight attribute in a variable, we are gonna use the set property to change the weight of
oh,
that.
so it's just changing the weight.
Yeah. And we, as we can see, the weight of the box it got changed. So this is gonna be like really useful for Amazon or someone that are trying to create their own open USD frame pipeline where they are gonna render the whole environment.
Mm-hmm.
And let's move on to the next code snippet that we do have over here. But let's take a look. Okay, as we can see, since no other value was provided for the bool, it says zero. Let's take a look what was over. Okay, it still says zero. Hmm. Okay, since no value was provided for bool, it's gonna pick up the fallback values, that
Yeah,
is zero.
default, the default
Yes.
values.
Yes. Now moving on to example three, grouping related properties with namespaces. When working with grouped or compound data from other sources, namespace prefix attribute provide a clean way to organize related properties together. This example demonstrates how to store sensor reading using namespace prefixes. Notice the double namespacing pattern. Okay, so we have Acme, sensor, and temperature. So the first namespace identifies the organization that creates these properties, while the second namespace, sensor, groups related properties together. This hierarchical approach allows you to both claim ownership of your custom properties and logically organize them into functional groups. So it's a common pattern when mapping compound data types from other formats into into the USD.
What does this mean? I double name spacing pattern, Acme, sensor, temperature. I know this. First namespace defines the organization, custom properties.
It's like
Yeah, yeah,
grouping.
yeah, yeah,
So
yeah, yeah, yeah. I know this. That this hierarchical approach allows you both to claim ownership of your custom properties and logically organize them into functional. Yeah, okay. It is common pattern when mapping compound data. Compound data? What is compound data? Compound
com-
data types.
data types who read like compound data types, like let's say you have multiple data like in sensor, you can have humidity, you can have other data as well. I think that's what it is talking about.
Referred to as structure aggregated types are data models that group multiple individual pieces of information into single cohesive package. In standard programming, common examples of compound data types include structs, records, classes, or dictionaries. It is not that, bro. It's this. It's not humidity,
Go
temperature,
down,
pressure, all
go
that
down,
shit.
go down. Take a
Yeah,
look at
yeah.
Acme sensor temperature, Acme sensor humidity, Acme sensor pressure. These combined profile makes it clear for any pipeline tool to convert these data separate database converter that these separate attributes conceptually belong to the exactly same data structure. What, dude? I was incorrect.
You were just reading over here, bro.
No, dude. I did not read over there. I knew it's going to be that temperature. What do you expect? You know, remember Professor Olmo,
The goat.
the goat, weather data,
Yo, Dr. Almo. A shout out. Shout out to our G
doc.
Doc,
All right.
the one and only.
So this hierarchical approach, blah blah blah. Okay, bullshit. Now we have temperature. Okay, we're gonna create. Oh, this is pretty simple. And then we're gonna set the documentation. We're gonna set the temperature. Okay, set the values for them as well. Okay, then we get the values. Okay, that was also straightforward. The code is pretty straightforward. There's nothing much complex about it.
One
And
second, bro. I don't understand what is
okay, what
compound data type.
for sure. Do.
I don't understand, bro. One second.
So
Includes,
compound data types are like you can have multiple data types, right? Okay, if you look at temperature, humidity, pressure, timestamp,
yeah.
when you look at them,
But what is compound about it? Like temperature is just a numerical value we are getting. It's
right?
like int data type, right? Or float data type.
But what I'm trying to say, look at the data types that you have over there. Look
Yeah,
at it up.
float,
Okay, and the last one.
string.
So there can be a lot of data types. You can have bool as well.
Yeah, so. So what
So
is compound? What does
so you
compound
are, you are
data mean?
you are accumulating different types of data types over here. That is
So
going
you're
to be
saying we are going to collect all this data in one data type.
now we are going. So over here it says it's a common pattern when mapping compound data types from other form. Oh, it's a, other formats. Wait,
Yeah,
from
yeah.
other formats. My bad, my bad. Let's ask perplexity. Explain this to a 10-year-old. Explain this to a 10-year-old.
In standard programming, common examples of common data type, compound data type include structs, records. It's saying some sort of dictionary, like, which has multiple key value pairs or something like that.
Uh,
This is like having and the passport versus loose index, single data types. Loose index cards scattered on a desk. One card says a name, another says a birth date, another says country. They aren't bound together, so the computer has to manage them completely separately. Compound data types, structured. This is like a passport booklet. It binds a photo, a name, a passport number, and an expiration date into a single
oh,
physical asset.
okay.
If you
Got
pass
it.
passport
All right.
or
I know what it is saying.
what?
So, for example, let's say you have a JSON object,
Mm-hmm.
right? In that JSON object, you have multiple set of key value pairs. So some of the key value pairs are temperature. Some of the key value pairs are let's say humidity, pressure, timestamp, right? So these are multiple types of data types that you will get in a format, and that is going to be JSON format over here, for example. Now,
Wait. You said what time? We're gonna get humidity, pressure, timestamp in key value format.
yes,
Why?
keys, other formats. It is talking about other formats. So the other formats can be record, you say list or anything, right?
Yeah.
So if you are saying anything, that means that the format you are getting can be JSON, can be a list, can be a dictionary, right? And when you try to import, but when
Mm-hmm.
you try to import them, USD is gonna organize them accordingly, like basically map them out. So it says over here, it's a common pattern when mapping compound data types from other formats,
Mm-hmm.
right? So when you have other formats, so over here I'm gonna go with just a JSON object, right? So if you open, like, just ask Gemini to create a JSON list with the temperature, humidity, and anything. Just ask him.
What? Create a.
Create a JSON object
Mm-hmm.
based on the above
Mm.
data,
Yeah.
right? So over here, wait, oh bullshit, that created something else. But ask him again. Create a JSON object based on temperature, humidity,
Yeah.
pressure, and timestamp, showcasing mapping compound data types from other formats. Okay,
Mm.
yes, now this makes perfect sense. Let's say you are getting this type of data, right? This is going to be a different format,
Mm-hmm.
right? And now from this, we are going to pick whatever value we want
Mm.
from it. So let's say we are going to pick temperature, humidity, and pressure only,
Yeah.
and we know what are the values and what are the data type for them. So this
Mm-hmm.
is going to be a compound data type. As we can see, we have string, we have type float, and we might
Mhm.
have some bool values as well that might exist over here. Since
Mhm.
this data set only has float, and a string, this is
Mhm.
not a complete compound, but you know what I'm saying over here, that you can get different kind of data, and when you try to import or map them into OpenUSD, that's how you will map them out by groups. So since this is gonna be this will come from a sensor, right? So if we take a look at the first line over here, organization, that is gonna be our first Acme. If we go take a look over here, Acme, and
First
then
line where? Oh,
uh,
okay. Okay, yeah, 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 yeah. Okay,
and
device.
then
Yeah.
this is device ID at sensor, right?
Mhm.
So we can group it in a like group that is going to be sensor, and what are the other values or the payloads that you are getting in that sensor,
Mhm.
right? So that highlights what that line means. That is mapping compound data types from other formats into USD, right?
Mhm.
So there can be different types of formats. So it can be list, dictionaries, or anything else
Mhm.
that you're trying to import two lists at a time that are defining, okay, this is only humidity, this is gonna be
Uh-huh.
only temperature, like that.
Uh-huh.
So that's what it means over here. This is what compound data type means.
Mhm. Okay.
Yeah,
So
ignore.
compound data type means like combination of all this data,
Yes,
like a key value pair. So USD path, value, unit, type.
yes,
Okay. So this is a compound data type in here.
yes. No, no,
So
no, no. The whole thing is a compound data type, not individual. Temperature,
you mean
humidity.
this?
Yeah. Since you are getting multiple values,
Mm-hmm.
since you are getting multiple values from a single list or single objects, and that will
Mm-hmm.
have different kind of data types that will exist. So we have string, float, and float. So there are two values, two different types of data types that are coming from that format, and then we have to map it appropriately based on our requirements, or group them.
So okay. So let's see over here. We group related sensor reading using namespace. Okay, Acme identifies the organization sensor groups the related properties. So Acme sensor temperature. Okay, and then humidity, pressure, timestamp similarly, and then document the custom properties. So we again set documentation. We are setting the metadata for each attribute. And then set sensor data reading. So we are setting a custom value over here using the dot set, and this is just doing dot get. So what was the example over here? Grouping related properties with namespace. Where did it group then?
Dude, we are grouping it based
Over
on
here.
actual sensor, yeah, directly. So the naming that we're trying to do, that is trying to group it. So when the user loads it,
Oh, over here, so we can see it under environment
yeah,
sensor. Okay. Hmm. Notice how all the sensor related attributes share
yeah, the
Acme
same
sensor
actual
prefix.
sensor prefix. So that
The
is the grouping
nested
over here.
namespace structure organization group already makes it immediately clear. Oh, so it's just metadata and it's not
Yes.
something.
So
Okay.
it's for us. It's for us. That's what I've been saying. Like
Hmm.
it's for us to understand.
Okay, makes it immediately clear both where these properties came from and that they belong together as a logical group. Even though they're separate attributes, this pattern is especially useful when mapping structured data types like structs or records from other data sources into USD. Custom properties in OpenUSD provides a versatile way to okay key takeaways. Custom properties in OpenUSD are a versatile way to extend the functionality of scene description, making them adaptable to various specialized needs. By understanding how to create and set and retrieve custom properties, we can enhance our OpenUSD workflows, better manage complex data in our projects, significantly improve the precision and efficiency of digital models, and build USD pipelines that are tailored to specific use cases. Okay. This is done.
This is done, right? Let's move on to the next one.
Active and inactive prims.
Active prims.
Oh, this
What
is
are
small.
active and inactive prims? So this is 13-second video, so for sure is gonna be the same thing that is written over
Yeah, we
here.
can just read over here. Model. Okay, active and active prims. Order active and active models. A non-destructive deletion of prim from a stage.
Deactivating a prim provides.
Bro, wait. Let me see if there is a video that explains exactly what a prim is, because I want to see.
You can hover over the prim. Like there was the video when we started, right?
Yeah, yeah, yeah.
It's
I
gonna
know.
be the same OpenUSD video.
Oh, some guy has done a video on this because I wanted to see if he has done more videos on this. Define prim dot versus. Okay, this is a. Oh, we can. Oh, this is a nice channel, bro. Because when we're gonna start working with this,
We will for sure learn more about it when we do hands-on experience.
simulate human knee
This is more of a
omniverse.
theoretical information we are trying to get, so that's why I'm not focusing on that information that much. Once you get more hands-on information,
Yeah, I'll subscribe to this. This guy's view email address. We can, call him on the stream.
no, not right now.
Not
First, we
right
want
now.
to complete the thing, dude.
henrylearns@gmail.com. Yes, sir. Okay,
First,
got
we
it.
will complete it and then we will call him.
Okay. Active, inactive. So you want to read directly? You don't want
Yeah,
to.
in OpenUSD, all prims are active by default. Making a prim inactive is effectively a non-destructive deletion of a prim from a stage. Simple. Deactivating a prim provides a way to temporarily remove or prune prims and their descendants from being composed and processed on the stage, which can make traversals more efficient. An active prim and its active child prim will be visited and processed during stage traversals and operation. However, by making a prim inactive by setting its active metadata to false, we prevent that prim itself from being visited.
Wait, wait, wait. Making a prim inactive is effectively non-destructive deletion. Oh, yes, we read the thing, right? In composition. In composition basics, that
Yeah,
like
yeah.
if there's a scene.
However, by making a prim inactive by setting its active
Yeah.
metadata, we prevent the prim from being visited. Yeah, yeah. Hmm. Stage dot get prim at path. Oh, okay, okay. So we use set active prop
As
API property,
false. Yeah.
and then we
To make
assign
it
new
inactive.
value. Is it true or is it false for that prim? So when we're trying to load using the get prim at path for slash parent, we can basically define, okay, should we
Okay,
activate it or should
so let
we?
me 1 second. I have a confusion. So let's say we have set this as false, right? Dot set active is
First of all,
false.
complete the fucking module. Then bring your confusion. It's
Uh,
gonna definitely answer your questions over there.
Okay, an
First,
active
complete
frame
the
and
thing.
its wait 1 second, 1 second. An active frame and its active child frames will be visited and processed during the stage and traversal operate. Oh, okay. However, by making a frame inactive by setting its active metadata to false, we pretend that frame itself from being visited. This also prevents its descended frames from being composed on. Okay. Deactivating, okay, so we are just doing false parent. Okay, so so everything under parent will also be set as false as active for
Yes.
active. Yeah,
Like it's
yeah,
gonna hide it. What prem is? Prem
yeah.
is a primary container object that can hold other prems.
Mm-hmm.
So it's like if you we can take an example of drop the menu drop downs, right? If you
Yeah,
expand one folder, You can see every other things in VS Code, and if you expand more, then you can see other things. Then you can start hiding the object
Yeah.
in the same hierarchical manner that you expanded them. Or
Okay.
if you don't want to see anything, you can just deactivate that the whole prim or that whole folder, and you won't be able to see the other things
Okay,
accordingly.
got it. How does it work? Deactivation is useful for managing scene complexity and scalability by pruning unnecessary scene data. It provides a way to non-destructively remove parts of the scene graph without permanently deleting them. When a prim is deactivated, it has following effects. The prim itself will be excluded from default stage traversals as determined by the USD prim default predicate. Okay, all scene description for the deactivated prim's descendants will not be composed onto the stage, correct? However, the inactive state can be overridden by stronger layer opinions that set the active metadata to true for that prim. Oh, liver peas
However, the inactive state can be overridden by stronger layer opinions. Opinions matters.
for stronger layers.
This allows selective reactivation of pruned subtrees. Makes sense. Working with
Selective
Python,
deactivation, yeah.
we can use the following Python functions to set the active metadata on a prim and check to see if the prim is currently active on the stage. So we have usd prim dot set active bool.
Yeah,
So it's the active
pretty
metadata for a
straightforward.
prim. Yeah.
Yeah.
Is active return whether prim is currently active on the stage.
Hmm.
Example one,
Read
setting
this,
prim
bro.
for sure. Setting prim as active and inactive. Active and active prim is a behavior that is non-destructive, as we read earlier, and provides reversible prim deletion from a stage. By default, all prims are active. Active prims are visited by stage traversals. If a prim is inactive, that means it is not visited by stage traversals, and neither will its child prims. USD set active is used to set whether the prim is active or inactive. Giving the value of false will make it active and true to make it. Oh, wait. Giving the value false will make it inactive and true to make it active. Simple as that. So if we take a look at the code base, simple thing, setting the file path, stage, setting up the stage, and then we are gonna traverse through the stage and get all the prim paths that we can get, and we are gonna get the prim path of what is for the world box, and then we are gonna set the prim inactive.
Mm.
Right. So if we take a look before activating and after activating activation, so when we loaded before deactivating the prim, we saw world, box, geometry, and everything getting loaded. But when we deactivated the prim, everything else under the box and the subsidiaries, subsidiary prim that resided in that box prim were hidden since after once we removed it or deactivated it. So over here the prim exists, but we are basically not rendering it. That's what it says over here. So key takeaways: the active and active behavior in OpenUSD allows for non-destructive pruning of scene data from the compose stage view. Deactivating prim helps manage scene complexity by temporarily removing unnecessary scene elements while still preserving the ability to reactivate them later. This pruning mechanism is an important tool for optimizing performance and managing large, complex USD scenes in production pipelines. Yep, that was easy, not bad. Moving on to model kinds. In this lesson, we
One
are
second, bro.
going
One
to
second.
talk concept of kinds.
1 second, bro. 1 second. Bro, before deactivating for prim and prim space also. Bro, they did not set stage.getPrim at path world box over here before this for loop. So how was this printed?
Go up. Do they did print get prim dot get path. Line, look at line 11.
Prim.getPath stage.traverse before
By
deactivating.
default, the prim is always active.
Yeah, but
By default, the prim is always active.
also it's coming from this active and active USDA file.
Yeah.
Stage this stage before for prim in stage.traverse. Print prim.getPath. But where did it's it's not set. It did not set anything, right? Like we have to set the slash world xform and then slash world
Already
dot.
in the asset.usda file. Why do you need to set it up? Like if
How do you think? How do you know it? But it's not loading. Okay, let me see
go look in your notebook. It will be already over there.
assets and what is that? Active and active USDA. I don't see it.
You are in Beyond Basics, right?
Yeah, and what is that? Active and active, right?
Yeah. The file should exist somewhere. You are not able to do it. Take a look at the file again.
Bro, it ran.
See, the file is over there.
Oh, active and active, yeah. So it already has this X form.
Uh,
Oh, okay, okay, okay.
like just don't go into like too much too deep. Just look at what the code base is trying to teach
I
you.
know, I know, I know.
Yeah, I used to do that, but then they have already taken care of those things, so we don't have to worry about that. It's more about like understanding the concept and what are they trying to teach us over
So
here.
they set stage.getPrim at path as box, and then they set active to false for box, and then they do a traversal again, get path, and this is inactive, so they only get the slash world slash box geometry. World box, geometry, materials, geometry cube, geometry, material, box slash materials, box, okay. So this was made inactive. So only slash world, slash environment, and slash skylight are active. Correct. Okay, we can move on. Key takeaways. Active and active behavior in OpenUSD allows for non-destructive. Yeah, bro, this is like the fifth time it's saying the same thing in the documentation. Reactivate them later. Pruning as another important tool for optimizing performance and managing large complex USD scenes and production pipelines. Model kinds. Let's go.
Let's go.
Oh, this is big. Okay. Model kinds are prim level metadata that classify a prim's role in model hierarchy. They are tokens from the kind registry that tools use to create a standardized query able structure independent of prim schema type. I don't understand what this means. Kind is not another prim type like USD geom scope or USD geom form. It is metadata that other tools and pipelines can rely on. With kinds authored, you can get authored You can target only models using USD prim helpers like is model, is group, is component, and is subcomponent. And you can traverse models with predicates such as USD. I don't understand this at all. What is this?
So I think based on it, what I am able to understand is it's more for metadata purpose of a frame.
Model kinds.
Yes, it says over there. So if you look at one, two, three, line three,
Mm-hmm.
uh, kind is not another prem type like USD geom or USD geom XFORM. So we already know what geom scope and XFORM is. It is metadata that other tools and pipelines can rely on. So it's more of a informational value, like what kind of prim is this? With kinds authored, you can target only models using USD prim. Helpers like is model, is group, is component, and is subcomponent. And you can traverse models with predicates such as USD prim is model as a rule of thumb. So based on my understanding over here, it says that if it's a model, is if it's a group, like initially we try to create some kind of attributes in a organizational and then group and then property manner. So in a similar
Mm.
way we can do it for prim. So if we go like more deep, understanding kind enables the creation of modular reusable assets, and employing them effectively can have significant impact on how well we can manage complex 3D scene. How does it work? Kinds are a set of predefined categories that define the role and behavior of different prims within the scene hierarchy.
Bro, wait. I'm gonna put this in Gemini.
Dude, just go through it, dude. Like you are not going through whatever they have done. That's why. Just go through everything first, then you put it.
Okay.
I'm definitely sure that you will understand it.
Okay.
So kinds are a set of predefined categories that define the role and behavior of different prims within the scene hierarchy. These includes group, assembly, component, and subcomponent. So group, assembly, component all inherit from base kind model, which is why we refer to them as model kinds. And subcomponent is the outlier. Model is an abstract kind and should not be assigned as any prim. This is what inheritance look like. So we have model, then component, then group, and then the assembly. So we have kinds are extensible, so you can add new taxonomies, but at the cost of content portability. Consumers need to know what your custom taxonomy means and how to reason about them. Refer to the kind documentation for blah blah blah. Okay, component. So one of the thing we have from kind is component. Let's start with the component. A component is a reusable self-contained asset that is complete and referenceable. Component is a relative familiar word, so it's helpful to think of a component model as a consumer facing product like a pen or a house. While drastically different in scale, both would be logically component models
Give
in a
me
high.
1 minute. 1 minute. 1 minute.
You just complete it. You definitely
Bro,
will.
I'm not understanding anything, whatever you are reading, bro. I'm not getting it. That's why
Because you're not
I don't
trying to
wanna.
read it, bro. If you're not,
Bro,
you always go to Gemini. Like if you just focus
I
on it.
am not
I've seen
reading
most of the time
Gemini.
that
I'm going up
whatever you're going
here.
through Gemini is already written in over here. For
Bro,
sure.
why I am reading on
You
top.
read
I'm
it.
not.
You read it. I'm going to read it over here. You read that. Do it. I'm
Okay,
for sure
you
doing that because eventually Gemini reads the whole thing
I
and
am
gives
not
you
reading
the
it
whole
from
thing.
Gemini. I'm not reading it from Gemini. I'm reading it from here. I was trying to understand this part. What is group assembly and component? Like these, 1 second. Metadata, blah blah blah, with kind of authored. You can target only models using. Now it's saying only models using USD prim helpers. What are these helpers? Is model, is group, and
So yeah,
what are they do?
as you go deep, you will get to know them. You What it's saying over there. Like, just follow the whole pattern. You will see the samples over there.
As a rule of thumb, groups and assemblies organize models. Components are leaf models. Models, subcomponents mark important interior nodes, understanding kind, blah blah blah. Creation of modular, reusable assets and employing them effectively can have significant impact on how we can manage. Okay, kinds are set of predefined categories that define the role and behavior of different prims within Oh, okay, now I understand. Yeah.
Okay, now Gemini first, and then Gemini is gonna say the
I
same
have
thing.
not read the same.
But
I
I'm
have not
telling
even
you,
read anything in
but I'm telling
Gemini.
you, Gemini is gonna do the same thing. Already goes through the whole thing, and it says you in a simpler manner. That's it.
These
Either
okay,
you
wait,
read
wait,
through it,
wait.
or either you read through that. It's gonna be the
These
same.
kinds of these kinds include group, assembly, component, and subcomponent. Kinds are predefined categories that define the role and behavior of different prims in scene hierarchy. These include group, assembly, component, subcomponent, group, assembly, component. Group is kind of model that contains other models, forming collection of models in model hierarchy. Assembly is a published asset that groups multiple models together into a meaningful collection. Component is leaf model in USD model hierarchy that represents a complete published asset, all inherit from the base kind model, which is why we refer to these model kinds. Subcomponents is an outlier model. Okay, subcomponent is a prim with subcomponent kind that exists within a component model. Model is an abstract kind and should not be assigned as any prim. This is what the inheritance structure looks like. Model, component, group, assembly, sub. Oh, do you understand this?
Yes. Like, if you go down, you will see what it is saying.
Model, component, group, and then assembly is under group, and then subcomponent is an outlier.
Yeah.
And what are they doing? They are just defining the roles of each prim in the scene hierarchy.
Yes.
Kinds are extensible, so you can add new taxonomies. Kinds are extensible. So these are all kinds.
Yes.
Okay, but at the cost of content portability. Customers need to know what your custom taxonomies mean and how to reason about them. Okay, that's why we were trying to come up with our custom taxonomy over there, something like that.
Refer to the kind documentation for more information.
Do you want me to open this
What?
kind in?
If you want to, like, it's gonna be more
It's just the
kind.
USDA thing. Oh, it's short. I can read it quickly. Kind library provides runtime extensible taxonomy as kinds. Kind are just TF token symbols, but kind registry allows organizing kinds into taxonomies related defined concepts and kind registry base kind. Blah 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 blah. Useful classifying scene graph objects. Tagging objects is built in the root of the model with the kind of model it represents. Its scene graph taxonomy that motivates the bulletin and hierarchy. The core kind hierarchy preloaded with the following hierarchy of kinds that define our concept of model hierarchy, which is so central to our organization discovery of scene description, of course, blah 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 blah. Okay, this is how it looks like. Extending this kind registry. The kind registry can be extended using facilities provided by plug registry by adding a kind subdirectionary. With your Pixar base aware build environment, dictionary entries will look like kinds, char group, assembly. Description of char group is an assembly of compromised or comprised of a single character plus some associated models, typically hair, garments, and char props. Char prop base kind component, new root kind, okay. One cannot alter kinds hierarchy. Okay, you need this more in depth later. Okay, kind component. Okay, what is this?
Basically, the same thing that you read over there.
Okay, component models can be thought of like consumer products, example, pen or a house, logical units in a hierarchy. Okay, model component. Okay, can't contain other components, so subcomponents are used to maintain separate asset identity within a larger hierarchy. Components cannot contain other components. Okay. A component's parents must be set to group or assembly kind. What? But over here, model component is different, like, and group and assembly is different. Why does it say a component's parent must be set to a group or assembly kind?
I think if you take a look at, there's more information about component over there. Go down.
Okay, wait. Okay, that's it for this. This is component. Let's start with component. A component is reusable, self-contained asset. Component is reusable, self-contained asset that is complete and referenceable. Okay, component
Modular.
is relatively familiar word, so it's helpful to think of component models as consumer-facing products like pen or house, while drastically different in scale. Both would be logical component models in hierarchy. Component models in hierarchy. Okay. Uh-huh. Subcomponent. A component cannot contain other component models such as descendants, which is why we have subcomponents. Subcomponents aren't model kinds, but they are way to identify that some prim within a component might be important. Oh, okay. Groups and assemblies. Zooming back to bigger picture, all parents of component models must have their kind of metadata set to group or assembly. A group is an organizational unit within a model used to logically group related models together. Similarly, an assembly, which is subkind of group, serves as a container for combining various parts of assets into larger, more complex entity. In this example, the house, in the example of the house as our component, the neighborhood or city might be assembly models. Oh, okay. I understand it now. The assembly model may contain multiple group scopes such as trees, street lights. Oh, okay. Trees, street lights in the neighborhood. Assembly model may contain multiple group scopes.
So
So
a component will exist, but it will be under the component, I think.
no, that's exactly what it's saying not is
Okay, so
not the case.
okay.
Components cannot look at this.
Sub no,
Mm,
sub I'm talking about sub components.
yeah,
Sub
I'm that
component cannot
up
contain other component.
yeah,
As
exactly.
yeah,
Descendants, which
they
is
cannot
why we have
contain component
subcomponents.
can contain subcomponents.
Subcomponents aren't model kinds. Yeah, they are not. That's why, bro, it is separate. It's not under component. It is a separate thing outside model kind.
Wait, let's see. Subcomponents is reusable self-contained asset. A component is relatively familiar word. So while restricted scale, blah blah blah.
Ciao,
So
chat.
going out bigger picture, all parents of a component model must have their kind metadata set to group or assembly. That's simple. A group is an organizational unit with model used logically group related together.
Mm-hmm.
Similarly, an assembly which is sub kind of group serves as container for combining various part of the assets into a larger, more complex entity. So in the example, a house as our component, the neighborhood or the city might be assembly models. The assembly model may contain multiple group scope such as trees and streets light in the neighborhood. So we have okay, but why does the image says showcases that window is a subcomponent, but
Yeah.
but component
Subcomponent is not something which is inside component. It is a separate kind. See, you're
but it
see.
would come under. That's what I'm saying. It would come under it, right or not?
No, that's what I'm saying. It would not come under component. Component is a different thing and subcomponent is a different thing. See,
Well,
like
yeah,
group.
what is well?
Say hi to the chat. There are a lot of people watching us.
Holy shit.
Five
Will
people.
component
What's up, chat? What's up, chat?
will
Guys,
subcomponent
type something in the fucking chat so that we can respond.
come under subcomponent?
What up, chat?
Not in the kind. Oh, it's a separate. So it's not in the kind hierarchy.
Exactly. That's
But
what
but
I'm
wait,
saying.
but in the scene structure, that's what I was saying. Usually an important prim
It is in the
inside the
scene
component.
description. It is in the scene hierarchy. That's I'm not saying that it's not,
Yeah,
but
it's in
it's
the
it.
scene structure. So yeah, that's what I'm saying. So it's since it is in the scene structure, it's important over there. Like basically when you visualize it in the scene, it's gonna be under the it's gonna be under the component, but in kind hierarchy, it's not.
Mm-hmm.
So all right. So a group is an organizational unit, right? Perfect. In the example of house as our component, code model hierarchy, premise of the group, assembly and component kind, and any custom kind inheriting from them make up the model hierarchy. This hierarchy is designed so that we can better organize assets in our scene. It facilitates navigation, asset management, and high level reasoning about the scene structure. We can leverage model hierarchy to prune traversal in the scene graph. For example, all ancestral prims of component models, when they are correctly grouped, are part of model hierarchy, while all descendants are not. What is model hierarchy? The model
That's what I was
hierarchy
looking for as well.
is an organizational system that creates a table of contents of important subtrees in a scene. Okay, so a system that creates a table of contents. I think it's a more similar to an index. We can leverage model hierarchy to prune traversal in the scene graph. For example, all ancestral prim of component models, when they are correctly grouped, are a part of model hierarchy, while all the descendants are not. Oh, I see. Wait,
I'm
let's
not able to understand this. Prims of the group, assembly and component kind. Assembly component group assembly and component kind and any custom kind inheriting from them.
make up the model
Model
hierarchy. What
hierarchy.
components are not basically will come under model hierarchy.
Exactly. Yeah, that's what I was saying.
Yeah, so that's what it is saying over there.
This hierarchy is designed so that we can better organize assets in our scene. Yeah. It facilitates navigation, asset management, and high level reasoning about the scene structure. Okay. We can leverage model hierarchy to prune traversal in scene graph. Prune traversal in scene graph. For example, all ancestral prims of component models, okay, when they are correctly grouped, are part of the model hierarchy, while all descendants are not. What does this mean? Why all descendants are not, but all ancestral prim
What are
com
descendants? Descendants are subcomponents.
subcom like not subcomponents exactly, but yeah, the things that come under component, I guess.
Yeah.
Like slash
So
world, like over here that we saw slash world, slash box geometry. So these would be like the
no, no,
descendants.
no, 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 no. I think it's gonna be the model hierarchy component. I think group and assembly won't come under it.
Mm.
But wait, frames of the group assembly. No, no, it says. But I think gonna be only subcomponents, nothing else apart from it. Since frames of the group assembly and component kind, it says in the first line, make up the model hierarchy. So
I
I
think
think
we're
this.
gonna understand in code implementation, I guess.
Huh?
I think we're gonna understand this in the
Yeah,
code
yeah, yeah,
implementation.
yeah.
Let's look
Uh,
at that.
there are few ways you can interact with model kinds using Python. From Pixar, import USD kind. So we are gonna use the model API. Oh, we have a new API now. that is gonna construct.
A USD model API on a prim. What
Yeah.
is?
Oh, and then we're gonna use get kind to get what kind of kind it is.
Where is the fucking? Can you hear the music?
Set kind of a prim to component. So prim model dot set kind dot tokens dot component. Return true if the prim represents a model based on the kind data.
Okay, this is that USD model API class reference. The first and foremost model quality is its kind. That is the metadata that establishes it as a model. C kind registry use model API provides various methods for setting and querying the prims kind as well as queries also available on USD prim for asking what category of model the prim is. C kind and modelness. USD model API also provides access to a prim's asset info data, while prim can host asset info. Common, it is common that referenced assets are packaged as models, therefore it is convenient to provide access to one from the other. Kind validation option for validating queries to a prim's kind metadata. Hmm. Okay, got it. So use USD model API prim return the kind of a prim model API dot get kind. Set the kind of prim to component prim model API dot set kind dot tokens dot component. Returns true if the prim represents a model based on its kind of metadata. 127. Mm,
The example shows the practical benefits of model kinds. Slash word is marked as a group, so children can qualify as models. Word component is classified as a component, and word makers is left
mhm.
untagged. Model
Hmm.
only traversal allows for edit only to the component, while the makers remain untouched. Okay, so line 3 to 7 creates the file path, stage, world X form.
Wait. What is this example for? Traversal with model kinds. This example shows the practical benefit of model kinds slash world is marked as group. Bro, I was right. Look at this. Slash world is marked as group, so children can qualify as models. Slash world slash components is classified as component, and slash world slash markers is left untagged. Model only traversal allow for edits only to the component while the markers remain untouched.
Okay.
Uh-huh. Ow.
Ooh, it's a freaking table. But this kind of complex, but all right. What
Yeah.
does the kind? Okay. Kind dot tokens dot group. What does this do again? Set the kind of prim to component. Oh, make world a group so children can be models. Okay. Oh, tokens dot group. Okay. We are using tokens dot group. That's why it's gonna be converted into group. Makes sense. And what does this do? Oh, okay. Set kind. Okay, we can use tokens dot component, tokens dot group accordingly to make define them for the model hierarchy. Okay, makes sense.
Mm-hmm.
Markers are not defined with anything, so non-model branch. Then we have points, perfect. Then there is a for loop that is going with the markers. That's okay. And then what do we have in line 25? We have components. Okay. Now this is the part where it gets interesting. Okay, now we are gonna create another prim. No, another, yeah, it's gonna be another prim definitely. And then we are gonna define it in the X form. And once we have that, then we are gonna define the kind to component using kind dot tokens dot component. And then on line 28, we are gonna define the
Body.
body, and in the body,
Bye.
in the
What's that body doing?
body dot create display color frame. So that is basically for the color part. And then we are going to use XFORM Common API for the body to set the scale. Okay, so body is not, yeah, no, wait. Body, okay, body will be the subcomponent, I would guess. No, will it? Do you think body will be the subcomponent?
One second, one second. Set the kind of prim to component. Set the kind of prim to
Let
component.
me ask Perplexity if body will
To
be a subcomponent or not.
set the kind of a prim to component. What
Just
is
look
that? What does this statement actually mean? Set the kind of a prim to component.
at
Like,
component groups,
yeah,
models.
yeah.
So when you define the prim as component, it's gonna be component. That's it. That's a API call that you're making to define the prim into a component.
So okay, so when it does this slash world a group, so children can be models.
So now it's gonna convert it into group. Tokens dot group.
Yeah, okay. Set kind. So this is setting the slash world group, slash world as a kind to group, right?
Yeah.
And then non-model branch markers utility geometry markers equal to USD geom dot scope define stage world. Okay, so this is slash world slash markers over here. Points A and point C are they have defined like a
Oh,
dictionary
okay.
for both the points, point A, B, C, and D. Uh, for name position in points dot items cone equal to USD geom dot cone define markers. Okay, and then cone. What is this for loop doing exactly?
That for loop is going through the points. Like if you take a look down.
Yeah, they are going through the points, but what? Uh, it's
So
just defining each point, right? And so
yes,
first line is defining each point under the slash world slash markers.
yes.
And then second line is creating an access attribute with
Along with the y-axis,
along the y-axis. Okay. USD geom dot tokens dot y. What does this mean?
geometric tokens along y. So I think it's gonna provide the attribute value, like which value, which geometric value is it gonna be on x-axis,
Mm-hmm.
y-axis. Since it is using the geom library, so I think it
Mm-hmm.
predefines it over there. This is something new that we're trying to learn over here. And then we're wrapping it into XFORM Common API and then doing the translation based on the positions we are getting from.
USD, okay, USD geom dot xform common API cone set translate POS position. Okay. So set translate and then pull for name and position in points dot item. So this is name and this is position. And over here it's setting translate as position. So this is going to come here. And then cone dot create display color primvar dot set gf vec 3f. Okay, cone dot okay. Oh, I get it. I get what it's doing. So what exact? So set translate just sets the position, right?
Hmm?
Let me ask this in Gemini.
Yeah,
What
yeah, no, yeah, it definitely sets the position along some particular axis.
of the cone, right? Okay, model branch. A component we want to place as unit. Yes, exactly. Okay. Uh, shoulder. Okay. Component USD geom.xform model branch. A component we want to place as a unit. Component is this USD model API component dot get prim set kind tokens component. Oh, okay. So now it's setting the this as component as model kind over
Yes.
here because kind dot tokens dot component kind dot tokens dot group over here and then kind dot tokens dot component over here. Mm-hmm. And what is the this is world xform dot get prim and this is component dot get prim. Mm-hmm. Body equal to USD geom dot cube dot define append component dot get path and what is component USD geom. Okay.
So over here, body is nothing.
Oh, okay, okay. Body is just a cube. Yeah, 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 I know. And then body dot create display color primary. Okay, this is just setting the color, display color, and then your X formable API body set scale. So it's just setting the scale. But now model only traversal affects model. Ignore markers. Okay. For prim in USD dot prim range stage dot get pseudo root. For prim in USD dot prim range stage dot get pseudo root comma predicate USD dot prim is model. If prim is component x formable equal to USD geom dot x formable prim. If x formable USD geom dot x formable. Okay, I understand. What is prim? What is this line? I understand what is inside the for loop,
Mm-hmm.
like the if thing. I understand this, but what is for prim in USD prim? What is this prim range? Stage dot root get pseudo root
I think
predicate.
this is similar to for loop. Like if we use for I in range, so this is specifically for prim range, I would say. But we can take a look and ask Gemini get pseudo root.
Ah, bro, I cut my eye,
You
like the
cut your eye.
eyelid,
My God,
eyelid.
Lord have some mercy.
I don't
But
know,
I'm
bro. It's hurting a lot.
hurting a lot. Put some haldi.
Fuck. Haldi.
Yeah, dude, that's the best antibacterial thing that exists.
It's not infected, bro. It's just cut.
No, it's gonna help you with
Desi nuskhe.
the scan. Dude, that's not Desi Nuska. That is, proved by the scientist. If you ask AI right now, it will gonna say you the same thing. USD dot from range. The scanner.
Followed with a
Okay.
filtered stage traverse.
Filter utility.
Oh, it's a
That's
stage
first
traversal.
traversal of the scene graph. Okay, yeah, that's a new thing we learned. And then the pseudo root is to tell the scanner where to begin, represented by the path slash. Okay, okay, that's just perfect. New, we learned a new thing. And predicate. What is predicate over here? The gatekeeper. This is the most important part of the line, as predicate act as a conditional filter. Prim. Oh, okay, okay, yeah, okay, makes sense, makes sense,
And
makes
then
sense.
what are they setting? Oh, USD dot prim is model.
So if it's going to traverse to only those components or the prims that have a model kind. So it's not going to traverse to body or markers over here. That's what it is saying, since they do not have a kind.
But they have a kind.
No, body and markers do not have a
Oh,
kind.
body does not have a kind, yeah.
Yeah, body and
But
markers both.
cone has a kind and
Where
component has a
where is
kind.
cone doesn't have a kind, and even markers do not have a kind, and there is no cone prim. First of all, cone is
Oh yeah, it does not have a kind, my bad. Only slash world as a
like
group, so
if you go
children
down,
can be
you will see the
models.
output. You will see the
Oh, okay, okay, okay. Look at this line. So all the children of slash world, like whatever we are using slash world, like this world xform dot get path for, they
Mhm.
are gonna be models.
Can be
S-
models. They are not gonna be models. That's a different thing.
Can be models.
Can be
Oh,
models and they are gonna be models. Both are different things. So if you remove that predicate, I'm for sure that it's gonna show you the markers and the body as well. That will come under component, right? So they can be model if you define them, but we have not defined body and markers as a kind. So that's
mm-hmm.
why we are not able to see them in the output.
So what if I remove this part over here? Predicate.
Yeah,
If
remove it. But I think it might ask for some other parameter, but let's see. Uh, yeah, yeah, do it, do it. Dude, why are you removing the
oh yeah, my
uh,
bad.
just remove that. Yep. And the comma as well. Yeah, now let's rerun. See?
Oh yeah.
So we had point C, point B, and whatever what other things. We had
Markers.
marker as well. But
Yeah.
the only thing that mattered to us was the prem that had a model kind when we use the predicate USD dot
Yeah. Okay.
model over here.
Uh-huh. Okay. So let me just quickly reread this part. Based on model kinds lesson you are viewing, that is a specific line for loop is filtered stage reversal. It tells OpenUSD can scan through scene graphs starting from very top. But only hand you the object prims that are officially classified as part of the model hierarchy. Uh-huh. This is the iterator utility in OpenUSD. USD prim range is the iterator utility. It performs a depth first traversal of the scene graph. Think of it like a file explorer that automatically opens every single subfolder and file one by one, so you don't have to write messy recursive code yourself. So USD.prim range is the scanner. Stage.get pseudo root starting point. This tells the scanner where to begin. Pseudo root represents the path slash is an invisible structural container that sits above all your actual root objects like world. Starting here guarantees the loop evaluates the entire stage. Predicate equals to USD.prim is model. Predicate acts as a conditional without it USD prim will return everything every mesh. Okay. It checks kind metadata badges, blah 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 blah. Okay. 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 So now I understand what this is doing. And then if prim is component, xformable equals to USD geom dot xformable prim. So if the prim over here is a component, it will become exformable,
Yes.
right? And
Yes.
then under that,
No,
also there is
it
one.
doesn't matter. It doesn't matter. Like if it's a component or not, it's still gonna be exformable.
If prim is a component, bro, over
Like
here,
you're
look.
checking, you're just checking. If you do not check, and if you still do exformable, it is still gonna go through it. But you're just doing making sure that whatever the prim that you are going through is a component.
Mm-hmm.
But I'm saying in general that if you do exformable equal to USD geom exformable prim to any other prim, it is gonna be exformable at that point as well.
Mm-hmm.
But over here, that for loop is basically saying as we are only checking for is component, because when you do traverse, you are also going to go through world, and world over here is a group, not a component.
Mm-hmm. I see. If exformable USD geom.xform common API set translate. Okay, this. Show which prims were considered models. Okay, so that's why we are looking at this.
Yeah.
And then they're getting printed over here. Stage.save. Got it. Cone A, B, A, so point A, point B, point C cones, and then one component is cube. Got it. Key takeaways.
Model kinds in OpenUSD provides a structured way to organize and manage complex scenes. By defining and adhering to these kind, artists, designers, and developers can create modular, reusable assets that can be easily combined, referenced, and shared across different projects and workflows.
Hmm. Cool. Stage traversal is next. Oh, this is long as fuck as well. But I think
Not
it's gonna
that
be
long.
easy.
Yeah, it's gonna be easy.
And how
Keep
long
it.
is Hydra?
Hydra is short.
Oh, Hydra is very short. So we can do
Unity is
Hydra
like
also.
simple as well. So
And
yeah, I
this
think
is
we'll be
long
able to complete the beyond basics today.
today. Yeah.
And then tomorrow we can do a quiz, a deep, in-depth quiz.
We can just dedicate the whole day tomorrow to like create like, solving our weak points in beyond the basics and doing the quiz.
Yeah, yeah, yeah.
So stage traversal. Do you want to take a short break or
Well, how long is this?
this is long? This is pretty long.
Okay, well let's just do what is state traversal, and then we will take a short break. Let's
Okay.
just keep the momentum. State traversal is the process of traversing the scene graph of a stage with purpose of querying or editing the scene data. We can traverse the scene graph by iterating through child prems, accessing parent prems, and traversing the hierarchy to find the specific prems of interest, as we did in our earlier example. That was in what was it? Oh, holy shit, I forgot. Oh shit, that was in model kinds. The snippet in which we are traversing through all the prems using the USD range.
Bro, 1 second. Let me use the restroom real quick. One
Okay,
second.
okay.
Yeah.
guys, I think there is some kind of activity going on in Pentagon right now.
What?
Domino's pizzas are spiking in Pentagon.
What is spiking?
Domino's pizzas.
What? Where are you seeing this?
On Twitter, brother, Twitter. There's an official channel named Pentagon Pizza Watch. Pentagon Pizza Watch. Yeah.
Mm,
And look at the latest post.
it's on May 20.
Go down. Yeah, 5 hours ago. This one.
Oh, okay. Extreme.
So I think war situation is gonna start again.
Ooh.
Ground invasion time.
Ooh. Bro, should we take any trades right now?
Now, dude, what are you gonna take? Like, go to Poly Market, you will find something. People are already betting over there. Yes,
Like,
1%, and
are we allowed
no,
to trade on Poly Market?
yeah, you're allowed to. It's like more like gambling. So gamblers are allowed everywhere. Since if you win, anyways, you're gonna pay 22 or 23% tax that goes to U.S. government. So no harm.
High activity. Damn. This is crazy. Oh, shit. Insane.
So usually, whenever there's a large amount of pizzas getting called in, that means
Yeah.
there is a lot of people that are over there.
What do you guys think, chat? It's spiking. Bro, I feel like we should sometimes like spin up our POV thing and
And look at what, brother. Look at what.
look at the situation in the
What
world.
a situation.
It's like, you know, Iran and Cuba in the same weekend. Pentagon Pizza Index is off the charts.
Oh yeah, Cuba. Like okay, Cuban government has been doing some shady shit as well. So I think you know the
Cubran.
global dominance should always continue. Cuban, crazy shit.
God damn, bro. 6 hours ago. Pizzato Pizza. Domino's Pizza. So what does this mean? Does it mean like there are like a lot of pizzas gonna be ordered because people are gonna stay overtime to manage some situation in the Pentagon or something?
Yeah.
Ah,
And the other thing is there are a lot of people over there as well. Like apart from the staff, some high profile,
yeah.
maybe president that
They
is
like
actively
pizza.
monitoring. What?
They like pizza.
Yeah, like that is the most staple meal that they assume. It has like 400 calories. And that is a go-to one.
I don't see a pizza box over here.
Why would they have a fucking pizza box over there? First of all,
Bro.
won't they be marketing Domino's for free?
Yeah. This guy, I think this guy in the background is looking at the pizza boxes because he's
Yeah,
hungry.
it's a pizza, bro. I'm so hungry. Can you order
Where's
some
the
Diet
fucking
Coke as well?
pizza delivery?
Yeah, can you order some freaking Diet Coke as well, Rich? And
This guy is just waiting
this
for
guy
him
should go
to
back.
take a
And
break and
what's
yeah.
going on, man? Are we gonna bomb the hell out of them?
hmm Son's wedding?
Will Trump, dude? People are betting. Is he gonna attend the wedding or not? Fuck it.
What the fuck has world come to? What the hell, bro? People really like this shit, huh? Our viewership just went up. We should fucking stop OpenUSD and start focusing on this
Yeah,
shit.
no one likes boring stuff, brother. People want one.
Polyglobe user experience aerial phenomena today.
Polyglobe.
Damn, bro.
Alright, bro, let's get back. What is
Chat, please. Do you
what
want? What do you want? Just put it in the chat.
like more boring stuff, brother?
More boring stuff. We're just gonna, go back to stage traversal. The fucking
What is
view, the views just show. As soon as I clicked on stage traversal, three people left.
like bullshit again, man. Bullshit.
God
What
damn.
is stage traversal? Stage traversal is the process of traversing the scene graph of a stage with the purpose of querying or editing the scene data. We can traverse the scene graph by iterating through the child prims, accessing the parent prims, and traversing the hierarchy to find a specific prim of interest. How does it work? Traversing stages works via USD dot prim range iterator. Other methods like stage.traverse that we saw earlier return a USD prim range iterator. The difference is that USD.prim takes prim range takes a starting prim as an argument, and USD stage.traverse starts its traversal from the stage pseudo root. Oh, okay, that's important. So
Wait,
traversal,
wait. So we can traverse the scene graph by iterating through child prims, accessing parent prims, and traversing the hierarchy to find specific prims of interest. Oh, let me play this. Oh, this is a. Can you hear this?
I don't want. Dude, it's gonna be the same. If it's a 2 minute video, oh shit, it's gonna be the same.
Page. This allows you to iterate over the scene graph, accessing, querying, and manipulating the prims, and it's a fundamental concept in OpenUSD. When you open a layer in a stage, you can traverse the scene graph using various methods. You can iterate through child prims, access parent prims, and traverse the hierarchy to find specific prims of interest. This process is facilitated by the stage object, which provides an interface to load, edit, and save USD data. Traversing stages works via the USD.prim range class, but you may often interface with it through stage.traverse. There are two traversal modes: default, which iterates over child prims; pre and post visit, which iterates over the hierarchy and visits each prim twice, once when first encountering it, and then again when exiting the child hierarchy. There are also predicates which can be used for pre-filtering the result. USD prim is active, looks for if the active metadata is true. USD prim is loaded, looks for if the ancestor payload is loaded. This one, USD prim is model, is looking for if the kind is a subkind of the kind tokens model. USD prim is group, looking for if the kind is kind, tokens, group.
Is
Is abstract,
abstract,
if the prim specifier is SDF,
defined
specifier
is
class.
instance.
Is defined, if the prim specifier is SDF, specifier defined. And USD prim is instance. This is looking for if the prim is an instance root. This is false for prims in instances. If you're writing code related to stage traversal, here are a few relevant Python functions you should know. This first function opens a USD file and creates a stage object. Stage.traverse traverses the stage of prims that are active. This function defines a predicate to filter prims that are active and loaded. This last function starts the traversing from the given prim and based on the predicate for filtering the traversal. In summary, stage traversal enables navigation and manipulation of the scene graph. It's essential for tasks such as querying the scene data and has numerous applications across various industries. Thanks for watching. If you'd like to learn more, check out the following resources and we'll see you in the next lesson.
Wait, bro, wait. 1 second.
More efficiently. Graph. Accessing, querying, and manipulating the prims,
What happened?
and it's a fundamental
I
concept
just
in
want to see what.
OpenUSD. When you open a
Again, I
layer in a
was
stage,
putting
you can
some
traverse the scene
medicine on
graph
my
using
eyes.
various methods. You can iterate through child prims, access parent prims, and traverse the hierarchy to find specific prims of interest. This process is facilitated by the stage object, which
Stage
provides an
object.
interface to load, edit, and save USD
Stage
data.
object which provides an interface to load, edit, and save USD data.
Traversing stages works via the USD.prim range class, but you may often interface with it through stage.traverse.
Oh, this is the here it is showing USD.prim range equals to stage.traverse. What?
There are two traversal modes: default, which iterates over child prims; pre and post visit, which iterates over the hierarchy and visits each prim twice, once when first encountering it, and then again when exiting the child hierarchy. There are also predicates which can be used for
Bro,
pre-filtering the
stop your
result.
vibrator, bro.
USD prim is
What can
active.
I do?
Looks
I'm
for if the
injured everywhere.
If the active metadata is true, USD prim is active.
active metadata is true. USD prim is loaded. Looks for if the ancestor payload is loaded. This one, USD prim is model, is looking for if the kind is a subkind of the kind tokens model. USD prim is group, looking for if the kind is kind, tokens, group. Is abstract, if the prim specifier is SDF, specifier class. Is defined, if the prim specifier is SDF, specifier defined. And USD prim is instance. This is looking for if the prim is an instance root. This is false for prims in instances. If you're writing code related to stage traversal, here are a few relevant Python functions you should know. This first function opens a USD file and creates a stage object. Stage.traverse traverses the stage of prims that are active. This function defines a predicate to filter prims that are active and loaded. This last function starts the traversing from the given prim and based on the predicate for filtering the traversal. In summary, stage traversal enables navigation and manipulation of the scene graph. It's essential for tasks such as querying the scene data and has numerous applications across various industries. Thanks for watching. If you'd like to learn more, check out the following resources and we'll see you in the next lesson.
Okay. So how does it work? I pretty much have a little bit of idea from the video. Um, but let's get into it.
Mm-hmm.
Traversing stages works via USD prim range iterator. Other methods like USD.stage traverse return USD prim range iterator. The difference is that USD.prim range takes a starting prim as an argument, and USD stage.traverse starts its traversal from stage's pseudo root. Traversals operate by walking prim by prim in depth first order. You can use predicates and USD.primRange.pruneChilds to optimize your traversals if you know you don't need visit certain branches. Okay. Traversing stages works via USD prim range iterator. The methods like USD.stage or return USD.prim range iterator. Uh-huh. Okay. Uh-huh. You can use predicates and USD.primRange.pruneChildren to optimize your traversals if you know you don't visit need to visit certain branches. What does this mean? Or prune children? It's just gonna set it to is active to false, I guess.
Yeah. Now, prone children means it's not gonna, like, let's say if you're traversing, wait, if you're traversing somewhere and you have multiple components, and those components might have some childrens. Those childrens are not gonna get traversed. That's what it means, I think.
Mm-hmm.
What the fuck are you doing?
Mm, I'm just trying to put it in Claude and learn
Uh,
this.
you can
Uh,
still ask Gemini.
I want to see it like visually.
Okay.
Oh, it created the whole thing for me. Yes, sir. Look at this. This is what I wanted.
World, box, XFORM, geometry. So, okay. What about what are you trying to do from over here then?
Okay, hit step or play to watch the walk. The key things in the page is fetching. The scene is a tree of prims. Every node is a prim with a type, world, and box are XFORM containers, geometry materials. Okay, and the leaves are blah blah blah. The path, the traversal is depth first, so DFS. Stage traverse doesn't go row by row. It dives all the way down to one branch before backing up. Watch the numbering. It fully exhausts world box. Okay, let me play this. Step one, two, three, four, five, six, seven, eight. Okay, okay, and then prim range slash
World
world
box.
slash
For a
box.
total box only.
Hmm.
Play, plate. See.
Yeah.
Oh, it's
And
gonna explore all the children of that box. Okay, traverse plus environment.
Traverse plus prune prune environment. So the it will not see any children of environment, I guess.
See.
Yeah, yeah, it's not gonna do it. Oh, play.
Play. Oh, okay, okay. So it's not gonna see any children of that. See, I was correct.
You're all so, bro. Can you
You
ever
know,
be wrong?
AI.
Can you be
There
wrong, bro?
are
Come
two
on.
traversal modes: default mode, iterate
Okay,
over
now I
children,
can come back to this.
and pre and post visit.
Ouch.
Iterate over the hierarchy and visit each frame twice, once when first encountering it, and then again when exiting the children hierarchy. Okay, visit each frame twice, once when encountering it, and then again when exiting the child hierarchy. Okay. Hmm.
There
Oh, okay, okay, okay. I see. It makes sense now. Hmm. Go ahead.
there are also predicates which can what does predicate mean? Which
Uh,
can be used for pre-filtering. Oh, okay. Predicate is just a filter.
User.prim is loaded. If ancestor payload is loaded. If prim is model. If prim is group. If prim is abstract. If prim is defined.
Hmm.
Working with Python, USD stage.traverse, USD stage.traverse all predicate, USD prim is active, USD prim is loaded, traverse starting from given prim based on predicate for traversal, USD dot prim range prim predicate equal to predicate, USD prim range stage if prim init prim dot get name.
Mm-hmm.
Oh, I see. Okay, are combined using a bitwise operator. Oh, okay, it does not use and. We have to use bitwise operators. What are bitwise operators? I forgot. What are bitwise operators? And means both condition together. Oh, okay, okay. Bitwise, all of that. Okay, perfect. Makes sense. Mm.
Okay. Pre-filtering the result. USD prim is active if active metadata is true. Analogous to USD prim is active. If ancestor payload is loaded, analogous to USD prim is loaded. Bro, I'm just gonna put this part in Claude and ask it
You
to
just
listen.
scroll down and you will see the code and everything, how we are using it.
Yeah,
Why don't you put the whole page into it to visualize?
I did. That's what I did.
Like no, do the whole page, na control A everything.
Bro, I did this. I just gave it the link to the whole page.
Okay. It's not able to do everything. No,
Huh?
do control A. You are copying the thing, na? Just do control A, and it's gonna take everything.
Okay, this whole section is really three separate ideas crammed together. The two entry points, prim range versus stage traverse, the two visit modes, default versus pre-post visit, and six predicates. Let me lay them out as three clean reference cards. Clean. First two ways to start a traversal, same underlying iterator, different starting point. Okay, both return USD prim range iterator. They differ only in where the walk begins. Okay. So USD dot stage traverse and USD prim range prim starts at the stage pseudo root, walks the entire stage, takes a starting prim you choose, walks only that prim subtree. Oh, I got it. I got the difference between both of them. Do you understand that? You are muted. Whatever you are saying, you are muted.
I was
You're muted again. I don't know what you're doing with your mic.
it's pretty clear in the snippet only what it is trying to do over there, and we did saw the examples earlier as well, so I did understood it earlier.
The Indian head bob. Yeah, yeah. Okay. The next two visit modes, the difference is how many times you see each prim during the depth first walk, and pre and post visit is what lets you run logic both on the way down into the subtree and on the way back up out of it. So next to visit modes, the difference is how many times you see each prim. Okay, default is each prim visited once, and pre and post means each prim is visited twice. Pre is enter, pre, exit, post. Pre on the way down, post on the way back up. Okay. One visit, enter, pre, exit, post. Uh-huh. Finally. The six predicates, each one is a single yes/no test on one property of a prim, and each has matching USD dot prim method that asks the same question about a single prim. USD prim is active, passes if the prim is active, metadata is true, that is not deactivated. Passes if the prim's ancestor payload is loaded into the stage is loaded. Oh, okay, okay. Model prim is group. Yeah, kind tokens group loaded onto the stage. Prim's ancestor payload is loaded into the okay, is loaded, okay. Abstract specifier is an abstract class template, passes if the prim specifier is a concrete definition. That's the whole section untangled, the mental model that ties it together. You can pick an entry point, whole stage, or one prim subtree. The walk runs depth first or in one of two visit modes, one per prim or twice entering and exiting, and predicates pre-filter which prims are eligible to be yielded at all. The predicate method slash method pairing in the last card is just saying the traversal level filter and single prim query ask the identical question. One decides inclusion across the whole walk. The other answers it for one prim you're holding. Okay, got it. Working with Python.
We have traverse, then traverse all, and
Well,
then we are going to use bitwise operators instead of typical and or not. That is the
uh-huh.
most important and critical information over here. So typically in Python we use
Oh
and.
yeah, this is the caution thing over here.
Yeah, so we cannot ever use and or not. We have to use the bitwise operator and pip and this symbol invert. Like what does it say? Wave? What is this symbol called? I don't know.
This one,
Yeah,
I wanted to learn that as well.
you can. Why don't you ask in the sidebar, Gemini?
I want to read more about it.
Read, read. It's gonna come in
A
IST.
tilde, yeah, tilde, yeah, yeah. I remember this. You know who taught
Okay,
me
so
this?
if you have did the same thing in that chat, would it have given any other different answer to you?
Let's
You
check
and
that.
what other information did you gain apart from the tilde? Okay, what other information did you gain? Now tell me. Huh? Like any historical information, it tilde comes from a Latin word till. Okay.
Okay, where is our page? Oh my God. Yeah, okay. If I had read it over here,
Yeah, yeah, let's see. What is the symbol? Okay, huh? I want to know. Is it gonna give us some other information? Oh my
tilde.
god! Oh my god! We have some wrong information, I would see, right? Incorrect information, fucker. We are missing that Latin origination, right? Latin origination from it. Till.
Duh.
Tilde originates from the Latin word till, and that's how there was a Greek philosopher who used to who was not able to draw a straight
Straight
line.
line.
So he started to draw waves, and that was like tilted lines. So then people started calling him Till, and then
Bro, because
Americans
of this conversation, you're gonna remember. Like, because
started
of this, you're gonna
calling
remember this lifetime.
Till.
Tilde.
Till the Greek origination. And in any interview, I'm gonna say, where does it originate from? It originates from a Greek philosopher. And then I will train an AI model to embed this logic. That fuck. That till originates from a
Often
Latin.
placed at the end of a sentence in digital messaging to signify playful, flirty, elongated tone. See, we didn't.
God, thank you. Much flirting. Shit.
This information is not present here, bro.
Crazy shit, bro. Crazy shit.
See, that information is not present
Crazy
here.
shit, it's gonna increase my dating game now. I know. Fuck. This is the only thing that I was missing. Now while chatting to a chick, I'm gonna do that flirty thing, and she will get, oh, this guy is trying to flirt with me, right? Fuck. That was the only thing that was weak in my game.
Okay. Bro, what? Bro, what? Bro, what?
Fucker.
Okay.
कहाँ चला गया था?
Bro, my Chrome crashed unexpectedly, but our stream is still live, so no
Crazy
worries.
shit.
Okay. Why the fuck my Chrome crashed? But I think we should have everything back running, I guess. Where is the fucking thing? I need the. Where is the fucking Claude? Oh, there it is. Okay. All right. Let's move forward. So this is the Python code.
Yeah.
Can you explain this part?
Which part?
Yes. Stage.traverse,
What is
stage.traverse
it
all.
explain? It's gonna traverse, it's not gonna traverse all. That is like literally written over there in the
Okay,
comments.
okay. My
Yeah.
bad. Active loaded defined non-abstract prims on the stage depth first. Say traverse all prims in the stage. All active loaded defined non-abstract. Okay. Predicates are combined using bitwise operators. USD.prim is active and USD.prim is loaded. Predicate. Oh, so we can set the predicate over here,
Yeah.
and then we can pass
Predicate,
this.
it's not necessarily, but it's basically for our understanding over here. You can set
So
if you
like, oh,
the
okay, okay, okay.
predicate over there, you can directly set the predicate like USD.prim is
Yeah,
active.
and then we can set this predicate
Yeah,
to.
but the predicate is a keyword or argument that it takes.
Mm-hmm. Okay, got it. You must use iter this
I iter operation operator.
iter
Okay.
iter to invoke iterator methods like prim range dot prune children. So it equals to iter. So prim in it. If prim dot get name. So if prim dot get name is equal to environment prim range dot prune children. So okay. So for a particular environment, we can set over here, and this basically for loop would skip those, you know, in the traversal, I guess. Skip all, yeah,
Like I think Lord Code already showed us everything over there.
over here.
Yeah, yeah, in that loop, in that demo it created.
Yeah, over
Travel,
here, right?
all, yeah.
Mm-hmm. Stage traverse, prim range, traverse plus prune environment. That's why it, yeah. Then I got some. Okay, this is bad predicate because it's using Boolean operator, which is not valid. We have to use bitwise operators and or and tilde. For reference, this is the USDA stage that we will be using in the following example. Okay, so look at this. Slash world war. Oh, so it already the Claude already gave us the whole thing, right, bro? What are you doing?
Nothing, bro. I'm already going through the example two over there. Like example one was pretty simple, and then that
Oh
was
yeah, yeah, yeah.
yeah,
To traverse the stage, we can use traverse method. This is traversal or active loaded down abstract. Okay. Okay, so stage traversal is not that bad. It's not that tough.
yeah.
Frame in stage traverse print. Okay. We can use the traverse method. This traversal will yield prims that are active, loaded, defined, non-abstract on the stage in depth first order. USD content for specific prim types. For this practical example, we will traverse. Okay, you're looking at example two, you said?
Yeah.
Did you already do it?
I was just going through the first four lines
Okay.
that we can filter based on type of prem.
Nice.
X scope or X form. Oh, nice. So okay, and so what we can use is for a valid prem. If the prem type does not match, it will return an invalid prem. Get prem dot get stage. Okay. So once we're starting to traverse, if prim is of type scope, your prim, then scope count plus equal to one. If instead of tribe, oh wait, we can further we will traverse. Okay, for example, we can check if prim is type scope of X form. Oh, I
For
see,
this
I see.
practical example, we will traverse.
So it's basically
Wait, let me read first. Let me read 1 second.
uh, hmm.
For this practical example, we will traverse the stage to operate on specific prims based on their types. We can filter based on the type of the prim. For example, we can check if the prim is of type scope or X form. Okay, so it's just gonna check if the prim is of type scope or X form. To do this, we pass the prim into the constructor method. For the prim type we are interested in, for example, USD geom.scope prim is equivalent to USD geom.scope.get prim.get stage and prim.get path. For a valid prim, what does this line mean, bro?
Which line?
This line, what does this mean? This is about a little trick for checking what kind of thing is this prim during a traversal. Here's the plain English version. When you walk the stage, each prim you get is a generic USD.prim object. Yes, it doesn't tell you upfront whether it's a scope, an X form, a cube, etc. Bro, do you remember what was a scope? Scope was the group, right? That grouping thing that we did.
Yeah. Scope dot USD geom dot scope. You can ask what is USD dot scope.
Array, bro, we did it in
Yeah, I know, I know. I'm just making sure.
this scope is a special type of prim that is used to primarily as grouping mechanism in scene graph. It does not represent any geometry or renderable content itself. It acts as a container for organizing other prims. Think of scope as an empty folder on your computer where you organize files. Similarly, scope helps in structuring and organizing prims within a USD scene. And this is how you do it. USD geom.scope.define stage, comma path. So this is gonna use to be defined a new scope at a specified path on a given state. So it's gonna get like a specific path and it's gonna create that scope on that specific path. And here, so def scope, and then that scope will contain sphere A sphere 0, A sphere 1. B scope B cube 0, B cube 1. Here like this. I remember this. Okay. So it doesn't tell you upfront what it is. It's whether it's a scope, an X form, a cube, etc. So you need a way to ask, hey, is this one actually a scope? The trick is you hand a prim to constructor of the type you're curious about. What does this mean? Hand the prim to constructor of the type you're. Oh, okay. USD geom.scope prim. It tries to interpret the prim as that type to outcomes. If the prim really is a scope, you get back valid scope object. If it's not a scope, it's an X form, say, you get an invalid object, basically a nope, doesn't fit result.
Yeah, it's grouping. Yeah, it's grouping.
Uh, wow. Tube light. If the prim really is a scope, you get back a valid scope object. If it's not a scope, it's yeah. And the convenient part, that invalid result is falsy. So you can just test it in an if. That's exactly what example 2 does. Oh, got it. I got it. So basically, what this code is doing is it's gonna say, okay, check if this is a scope. And if it returns invalid, it's gonna get into the if loop, the if else thing, and then it's gonna say if it is invalid, then check if it's an X form. And that's exactly what they are doing.
Yeah.
So if USD geom dot okay for prim and stage dot traverse
So if it's a
scope,
prim,
and
then
they're
it's not
okay, they're
allowed to
setting,
pass.
they're initiating scope count and X form count as
Yeah.
0. Right, and then they're doing like a for loop, and in that for loop, they're checking if the prim in the stage dot traverse. So where are they setting the stage dot traversal? Stage dot traverse. If USD geom dot scope prim scope count equal to plus, yeah, so they are increasing the counter by one. If it is a scope, print scope type prim dot get name. Check if the prim is type of X form. Else if USD, okay, so if it is not a scope, it's gonna say okay. If it's not a scope, then check if it is a X form. And if it is an X form, just create the counter as one. Uh-huh. Oh, okay. I understand this. But I'm not able to understand the stage dot traverse part. Why are they doing it in this, bro? Why are you fucking looking into your phone?
Because, dude, what do you want me to do over here? Like, it says that if it's a
What
X
is
form,
stage dot
then
traverse
it's
over
gonna
here?
validate,
Tell me.
otherwise it's gonna reject. That's what it is doing over there, and it has already said it in the about. Like, is it gonna be equivalent to
What is
something?
stage dot traverse?
It's gonna traverse
What,
till the
but
end.
what is that? Prim
Like,
in
what is
it's
that? What
some
do you
sort
mean?
of,
It's basically for I in range loop, basically for I in this. So for prim in stage dot traverse,
yeah,
it's
but
gonna
where is this range? What is this range?
until the end. Until the end, and there is no range defined. That is the best part of that traverse. See, it
Stage
says over there.
over here, right?
Yeah, until the end, everything.
Mm-hmm. You're right. Okay. Okay, I got this. Example three. You did example three also.
Example three. No, I did not. Wait, can be powerful tool, but for large scale, more efficient targeting. Oh yeah, this is the no. I did not. My bad. But for large stages, a way
Oh,
to be more efficient and target is to traverse through the children of a prim. If you need to work with a specific scope or hierarchy in the stage, you can perform a traversal starting
mm-hmm.
from a particular prem. Let's take a look at how we can traverse through the children of the default prem. Blah blah blah. Okay, we got a default prem. Iterate through all the children. Oh, get all children. Oh, yeah, that's also easy. We are using the get all children API to basically load all the children of that default prem and then
This
traversing.
one, right? USG dot state dot traverse
No, no,
all.
no, no, no. It's not that. It's something else. Just go look at the code.
You using traverse can be a powerful tool, but for large stages, more efficient and targeted methods should be considered. A way to be more efficient and targeted is to traverse through the children of a prim. If you need to work within a specific scope or hierarchy in the stage, you can perform a traversal starting from a particular prim. Let's take a look at how we can traverse through the children of the default prim. Oh, okay, powerful tool for stage of more efficient and targeted method should be targeted. Uh-huh. USD dot stage equals to USD dot stage dot open. Open a USD stage from specified file. Okay. Get the default prim of the stage. Get the default prim of the stage world in this case. So default prim USD dot prim equals to get stage dot get default prim. Okay, iterate through all the children of the default prim for child in default prim dot get all children. Yes. Print child dot get. So this is just basically just getting a
Yeah.
default prim and okay, yeah, we
But
can
the most important thing is we are getting the children of the default prim
default
that's
prim. Yeah, yeah, yeah,
like
yeah.
so over here it's showing that if you select a prim, you can
Let
use
me
the get all children.
see in the notebook what this stage dot traversal. Oh, I think we have to run this. Yeah, आएगा यासम आएगा. Okay, stage dot reversal. This is the stage dot reversal.
Mm-hmm.
So the default prem is world and world box geometry cube material box mat and environment and skylight. So all of this is under xform world, right? But they're only getting the child dot get path. So they are only getting box and environment because that's the direct child
No,
of
they are
world.
getting all the children's.
Bro, look at this. Look at the output.
But how do you know what do you have in the USDA?
What USDA?
The file that we're looking at.
This one.
Yeah.
Bro,
What is
because
that?
I have this open in my fucking thing, notebook. This is state
Box
traversal.usda.
environment. We're not getting all the children's.
Bro, because world, this only box and environment are the children of world.
Oh, okay, okay. Get prim path at. Oh, it says that. Oh, okay, 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 okay. Get prim path. Wait, what is the default prim? Default prim is world.
World. Look at this. World.
Oh, okay, that's why. That's
Default.
why. Because the entry point is world, that's why we are getting
Yeah.
the like that. But it says get all children.
Yeah,
And
but get. Okay, we can ask Claude actually.
yeah.
In the example 3 over there, the default trim is the slash world and the direct children are box slash box and slash environment that is getting printed when passing the default prim dot get all children for loop. Why are the other children of box and environment not printed when done? Print child dot get path. Because get all children only goes one level down. Look at this.
Okay,
It
okay, okay.
returns the direct children of the prim you call it on, not the whole subtree underneath. When you call default prim get all children on world, ask who sits immediately inside world. The answer is just blah blah blah. Never opens up a box and look geometry material and all that bullshit. They are children deeper, so a loop runs exactly twice, once per child, and prints. Okay, so over here the animation that we saw, uh, prim range world slash box. Mm-hmm. What? How is it? Okay. Do you understand it now?
Yeah, yeah, I get it.
Mm-hmm. Traversing US using USD dot prim. Now it's gonna use the prim range. So we
Mm-hmm.
can, yeah, this is easy. I think we already saw the thing over here. Prim range slash world slash box. So import the USD module, open your USD stage. Prim range equals to USD dot prim range. Stage dot get prim at path slash world slash box for prim in prim range. Prim, yeah, this is very easy, straightforward.
Mm-hmm.
Holy shit, stage traversal is done. And it was not easy,
Key
but
takeaways. Traversal is how we navigate the scene graph and query scene data.
wait. Let's do one thing first.
What?
I want to see the example for. Oh, this is new. Gemini, ask Gemini just directly by copying this.
If you-
Okay. Yeah, so this was not in the documentation. I think we should open an issue for this part.
What?
The predicate part is not in the documentation.
Just click on the predicate
Hmm?
and click on the USD prime range in Python. You'll, I think, you'll
That
have.
is in USD. That is in
Yeah,
USD.
so that is coming from USD only, brother. Look into it. You will find that predicate also. So if you want to go more deeper, then you go into the documentation.
But I don't see the predicate usage over here.
You are
Prim
looking in
range.
C++ first of all. Search command F predicate.
Oh, this is Python. This is prim range. Okay, whatever. We can do that later.
Mm.
Hydra. Oh no, we left key takeaway. Traversal is how we navigate the scene graph and query scene data. Traversal can be made more efficient by limiting the number of prims it
If you click on
visits.
predicate, you will see more about predicates.
Hmm.
If you click on predicate,
I clicked on predicate. This is what opened.
yeah, that's what I'm looking at as well. Prim flags, file reference. Oh, predicates are nothing, brother. Predicates is like defining like whatever we are seeing.
Filter. It's like a
Yeah,
filter.
that's it.
I
So
know what it
either
is.
you pass a predicate
Like
directly, or
this. Yeah, like
yeah,
this.
yeah,
I know.
yeah. That's it.
Bro, I understood it in first documentation only. I was just trying to see the example of the usage.
Mm. I think we once we go more deeper, we will get to know how to use them.
Bro, we are going deeper every day.
Yes, more,
You say this
more,
every
more,
day.
more,
More, deeper,
more,
deeper, deeper.
more, bitch. Uh,
Key takeaways was how we navigate scene graph and query scene data. Traversal can be made more efficient. Yeah, okay. Hydra. Second last. I'll play the video. In this lesson, we'll explore Hydra, a powerful rendering architecture within OpenUSD. Understanding Hydra enables efficient and flexible rendering of complex 3D scenes. I think I might skip gym tomorrow again. Uh,
and,
or I'll
uh,
just go and do recovery tomorrow.
in this lesson, we will explore Hydra powerful rendering architecture within OpenUSD. Understanding Hydra enables efficient and flexible rendering of complex 3D scenes. Hydra is a rendering architecture within OpenUSD that provides a high performance, scalable, and extensible solution for rendering large 3D scenes. It serves as a bridge between the scene description data such as USD and rendering the backend such as OpenGL or DirectX.
Hmm. Okay, I'll play this.
In this
Mhm.
lesson,
Three
we'll explore
minutes.
Hydra, a powerful rendering architecture within OpenUSD. Understanding Hydra enables efficient and flexible rendering of complex 3D scenes. Hydra is a rendering architecture within OpenUSD that provides a high-performance, scalable, and extensible solution for rendering large 3D scenes. It serves as a bridge between the scene description data, such as USD, and the rendering backend. The open and extensible nature of OpenUSD means it supports many different renderers, like Arnold and RenderMan, and OpenUSD's included Hydra Storm renderer offers a simple way for developers to visualize data out of the box. It has three main parts: a scene delegate, which provides the scene information, the render index, which keeps track of changes and manages the scene, and the render delegate, which uses both the render index and the scene delegate to visualize scene information to create the final image. Hydra operates on one or more scene delegates, which is a hierarchical representation of the scene data. It processes the scene delegates into an abstract renderable scene, which the render delegates can use to generate rendering instructions tailored for the specific rendering backend. This approach decouples the scene data from the rendering backend, allowing for flexibility and extensibility. Hydra supports various render delegate plugins, enabling developers to create custom rendering backends or extend existing ones. OpenUSD ships with HD Storm, a real-time rasterizer render delegate with OpenGL, Metal, and Vulkan implementations. HD Storm is leveraged by USD View and many other tools. Hydra also ships with HD Tiny and HD Embry, which can be used as examples of how to implement render delegates. Understanding Hydra enables efficient and flexible rendering of complex 3D scenes. In this lesson, we learned Hydra is a rendering architecture within OpenUSD that bridges scene data and rendering backends. It operates on a scene delegate and enables render delegate plugins to generate rendering instructions for specific backends. Hydra supports various rendering backends and techniques, including rasterization and ray tracing. It provides extensibility through plugins and custom rendering backends. And developers can interact with Hydra using Python bindings. With its support for various rendering techniques, extensibility, and decoupling of scene data from rendering backends, Hydra empowers users to create work in large scenes. We
I did
encourage you
not
to explore
understand
Hydra
shit.
further and
Yeah, Hydra is a really complex thing. But I think we just need to know the theoretical knowledge right now.
Let me put this and visualize this shit.
Okay, you are visualizing a video more.
No, not visualizing the video.
I see. You're trying to visualize a video that has already visuals. I understand.
Bro, easily, not.
For sure. You're trying to visualize something that they have already visualized. It's a next level of
The
visualization.
fuck is this?
Like over here.
Wait. Oh my god. Hydra sits in the middle so that scene data and renderers don't have to know about each other. Let me build the mental model in two passes. First core middle layer idea, then three parts and how data flows through them. Here is the central problem Hydra solves. Without it, every scene format would need custom code to. Okay, so it's basically a compiler.
Yeah.
It's like a compiler that converts the USD data
No,
into.
no, that does not. I think it. it
It
wait.
wait.
So it's gonna, I think, divert and select appropriate rendering things. Like let's say you're
Mhm.
getting a data, and that data needs to render in a specific manner. So Hydra act as a performant layer and optimizing and selecting those Storm, Arnold, and Render Man accordingly. I think.
Wait. Here's a central problem Hydra solves. Without it, every scene format would need custom code to. Okay. Without a middle layer, every source wires to every render. So USD scene is this, other data is this. Okay. Tangle of custom connections. With Hydra, each side connects only to the middle. Uh-huh. In the top half, the new renderer means wiring it to every data source. In the bottom half, Hydra absorbs the chaos. Your USD scene only ever talks to Hydra, and any renderer only ever talks to Hydra, swaps storms out for Arnold, and your scene doesn't change at all. That's what decouples the scene data from rendering backend means in plain terms. Decoupled scene data from rendering backend. Now the three parts. They're best understood as an assembly line. Data comes in one side, a picture comes out the other, with a manager in the middle tracking what changed. USD scene data comes to scene delegate, reads the scene and hands it over. Render index tracks changes, manages the scene. Render delegate. So render index and render delegate talk to one backend, Storm, Arnold, etc. Final image. Tracks changes, manages the scene. Okay. Reading it, that left to right simple analogy. Think of it like in a restaurant kitchen. A scene delegate is waiter who reads the order, your scene data, and brings it back to the kitchen. Its only job is to provide the scene information to Hydra in a form Hydra understands. Okay. The scene delegate is the waiter who reads the order, your scene data, and brings it back to the kitchen. Its only job is to provide the scene information in a form of Hydra understands. In a form Hydra understands. Is the who reads the order your scene data and brings it back to the kitchen. Job is to provide the scene information to Hydra in a form Hydra understands. Scene delegate is the okay. You can have more than one. The doc say Hydra operates on one or more scene delegates, which is how multiple data sources feed into a single rendered view. The render index is the kitchen order board expediter. It holds the abstract renderer neutral version of the scene, abstract renderer neutral version of the scene, and crucially keeps the track of what changed. When you move one object, it doesn't reread the entire scene. It doesn't reread the entire scene. It knows just that one thing is dirty and needs redrawing. That change tracking is a big part of why Hydra scales to large scenes. Mm, the render delegate is the cook for one specific cuisine. It takes the managed scene from the render index and produces actual rendering instructions for its backend. HD Storm cooks. Bro, did you understand everything?
Dude, I went through this. Like, if you go through what they have, like, you're basically overcomplicating the stuff over there.
Okay, explain. What did you understand? You
So
read,
I
right?
understand Hydra has three main parts. That is a scene delegator, so which decides what scene we are gonna provide, and then we have the render index, which keeps the tracks of the scene that are over there, and then we have the render delegator, which uses the render index and scene delegator to visualize the scene and the information that we need to create. That is the only thing that we need to focus on. So the only three main parts are, so how the scenes are getting delegated, which are going to provide the information, and then the index that keeps tracks of the scene when the scenes are in a motion. So we can have multiple scenes that we're trying to animate. And then we have the delegator. So that is the only thing that I understood, and that is the most important thing over here, I guess,
Mm-hmm.
about Hydra. And then it talks about different kinds of plugins and everything that Hydra can integrate into OpenGL, Metal, Vulkan, Rend, and all those things.
Mm-hmm.
And Arnold and Renderman are like different kind of renderers it supports.
What is Arnold and Renderman? The renderer.
Renderers, like the way, I think it's a way how you can render some things.
Okay.
Like there are, it's and bits around Hydra, but the most important thing that Hydra does is delegating the scene, selecting the index at which what scene should be there, and managing the where that scene would be at what point of time, I think.
Mm-hmm.
We are trying to visualize it.
Mm-hmm.
Because in key takeaways, it specifically says each and every point. Hydra is rendering architecture within OpenUSD that bridges scene data and rendering backends. It operates on a scene delegate and enables render delegate plugins to generate rendering instructions for specific backends. And Hydra supports various rendering backends and techniques, including rasterization and ray tracing. So these are like more in detail information of how different things can be rendered. So ray tracing is basically like to creating shadows. What in games we can see some shadows or details of in-depth scenes that is happening. So that is one of a way to render some things. And then it provides extensibility through plugins and custom rendering backends. So over here, the custom rendering backends and plugins are gonna be, I think, HD Storm, OpenGL, Metal, Vulkan. These are the libraries that most of the games uses. Like, cause I do remember when I was trying to download GTA 5 or something, I was missing a Vulkan package that is a C++ compiled package in which
Mm-hmm.
all the rendering scenes and everything gets compiled.
Mm-hmm.
Yeah.
I see. Hmm. Hydra operates on one or more scene delegates, which is hierarchical representation of the scene data. It processes the scene delegates into abstract renderable scene, which render delegates can use to generate rendering instructions tailored for specific rendering backend. This approach is decoupled the scene data from rendering backend, allowing the flexibility and extensibility. Hydra supports various render delegates plugins. Bro, I think this is important because this is the kind of thing we are missing for creating that pipeline, you know.
This is something that NVIDIA has already created.
No,
Okay.
I'm not saying we want to create this, you fucking
Mhm.
idiot. I'm saying this is the kind of information and knowledge we are missing because which we need.
OpenUSD certification is the key. That's why I was only saying that.
Fuck you.
OpenUSD certification. That's it.
That's it. Our viewership has dropped from we are way past our peak now.
That's fine.
We peaked at 7 viewers concurrent today, and now it's
Crazy,
just two motherfuckers watching us. I don't know who they are.
crazy shit.
Say hi in the chat, bro, if you're watching.
Ghost. I. Oh,
What?
bro, so sleepy. Next,
Bro,
what is next? Units and OpenUSD. How long is this, bro?
oh, there's only one concurrent viewer now.
An assembly scene. You just abused them with the motherfucking tone.
And they
So
left.
they left that. Okay, who are those motherfuckers that they were watching us and then
They're like, okay, fuck you.
when assembling 3D content from various sources, whether
What
created
are you
in.
reading? Okay, this part. Bro, this is long. Oh shit.
Bro, I'm done. Uh, the
You're
What is the stream time right now?
I don't know. 3 hours, 8 minutes.
Okay, yeah. I'm not able to focus anymore at this point. Like, cause I know for sure I would have to go through this again tomorrow.
You're right. I
Yeah.
think.
I'm
But
also I'm slacking
fuck.
a lot, so I don't want to waste and push myself on.
Last, but mm,
Like we can, but I know for sure it's not gonna hit it the way we went through the model kinds and stage traversal and
hmm
after prims custom properties. Like we got to know each and every detail of that.
hmm Okay. Yeah, we can do that tomorrow.
Yeah.
And then we can go do like a revision for the
Yeah,
whole.
we can do a revision and then we can do a quiz.
Yeah.
Okay. All
And
right.
do you wanna take a look at this 1 second? It's nothing crazy. Where is that fucking quiz that I had open? Drake songs are playing. You know, Drake released like 3 new albums.
Crazy shit. Oh man.
All these Drake songs are playing in the background. Failed.
Crazy shit.
But I'm trying to see if, yeah, I think these kind of tests are not gonna come in our fucking retake test, practice test, begin test. USD shade shader prim type. What is the purpose? Describe the material properties of a shader, encapsulate a shader program, parameters. Maybe. Neat, baby. Ooh. To encapsulate shader program and its parameters. I think
What is wait? How can you create a custom schema by creating a new file by writing a script by using special schema tool editor by modifying his
we have
existing.
not done this yet.
Wait. We have done that, dude. We have done it.
Custom
Wait.
schema.
Yeah. We have. We did take a look at custom schema sample. Wait. Let me try to answer it. Using special user schema editor tool. I think C would be an answer.
No.
Wait. Yeah, define
By
new.
writing a Python script that defines the new schema. I think it should be B, but it can also be D.
D.
It can also be D.
Modifying the existing built-in schemas.
Yeah.
No, I don't think so. Like
I think it
that.
should be B or D.
So one of the fundamentals of OpenUSD is non-destructive behavior,
Yeah.
and D promotes destructive behavior at this point. So if you're trying
That
to,
is for prims, bro. That is
no, but so wait, premise. Okay, where do schema comes under?
okay. You're saying it cannot be D.
Yeah,
Okay. Yeah, B is correct. By writing a Python script that defines a new schema.
script, dude. This is so like misleading. Script writing a script is so misleading at this point. It should be a function or something. What is
What is a
delegate?
delegate? Yeah, we just did this,
We
right?
just a class that translate USD into render specific format.
What is a delegate in the Hydra rendering architecture?
Dude, it's gonna be A. I think.
A class that
Yeah,
translates
it's
US
gonna be
data
A.
into render specific format.
Yeah, it's gonna be A.
Animation, geometric shape, material. Yeah, it's easily A. Yeah. You have
What?
an asset with color variants set red and blue variants. How would you access the currently selected variant using Python prim dot get variant, active variant, variant selection, get current variant?
Wait, I think it should be a get variant value. Oh no 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 no! It should not be. Why are we looking for value now? Get variant selection.
I think it
Get
should be
variant.
D if I don't know. Selection. Oh
Uh,
no, it's C. It's C. I think it's C. Because we
see,
have to set the variant and then we have to select the variant. So
okay.
it would have already set the
No,
variant
so
somewhere in the code and then variant selection. Get variant selection.
okay. See, I think
I
yes. See,
think it should be C.
RA.
Yes,
Let's see.
sir.
Yes, value because value doesn't make sense.
Yeah.
What is
What is the
primary?
primary benefit of USD is variants that apply different material, different alternative
B
representation, create different version of an asset level. Yeah, it's
B B
C.
B B. Wait, two
It's
defined
C, bro. It's C.
different for different purposes with variety. Oh yeah, C is gonna be C.
Organize assets into logical groups. No. Oh, it was B. My bad. To
Two
define alternative representation
Because
of
this,
an a.
this is a line that is written in the documentation like alternative, but I was confused with where it did not said like level of detail and
I mean, it can also be this. Oh, this describes LOD is not
representation.
necessarily a
Yeah,
key purpose of variance.
representations.
Oh, there is AI also over here, you know. Explain this further.
Same shit. AI, 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 AI. Every other freaking company. AI.
What do you want to keep doing this? There are like
Let's do
200.
till 10. Let's do till 10, not. Let's do till 10 only.
Okay.
How can you get the current value of a
Of
timestamp
time
in
sample.
C? I think get method is the most basic
Yeah.
one. But I think if this is the kind of question they're gonna ask,
I don't think so.
yeah,
And it's gonna be multiple choice, not one.
7. A studio wants to implement OpenUSD in the pipeline. What is the critical first step they should take? Hire a OpenUSD team.
And a team of USD experts. So manage the entire transaction.
Because it's the
Purchase the
most
most expensive USD compatible. I want to know the answer to this question, bro.
great.
Comprehensive schema tailored to their
USD schema tailored to this specific
train
asset.
all artists on advanced features of USD. Immediately convert all existing assets to USD format.
I think it should be D or C.
C, I think.
Now, immediately convert like USD. OpenUSD already allows you to convert everything, right? And it has the flexibility. So I think the schema would be the most appropriate answer.
Like I think E can also be the answer over here.
A, B, C, D, E. Like sorry, yeah, developer comprehensive. Yeah, that's what I was talking about. The last option.
I think it should be C or E. Let's see.
Okay.
What? Oh yeah,
Yeah.
your answer is correct. This is the correct approach to ensure consistency and compatibility. Overall explanation, developing a custom USD schema is crucial because it defines this data structure and relationships specific to studios, assets, ensuring consistency, efficient workflow, implementation domain. Okay. How can you create a new USD stage from scratch using Python USD stage dot create new by custom blah 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 importing pre no. I think it should
Stage
be
dot
a
create new. A.
USD dot stage dot create new function. Weren't we using USD dot stage dot define or something like that?
But that was for defining, not for creating a new stage, right?
Yeah.
Yeah.
Dot create new
Like, and it's all on camel case. What is the primary purpose of USD looks like to define
lighting,
a
light
C?
sources.
Yeah, easy peasy. Then how
How
can
can you
you
set current variant and variant set on USD? Set variant
by
selection method. I think this
yeah,
one.
by creating separate by custom. Oh yeah,
By
E sorry
directly modifying prim properties, creating a separate USD file variant.
E.
एक second, 1 second. How can you set the current variant in a variant set?
Set variant selection. Like apart from the answers we have, either it's gonna be none of the above or it's gonna be E.
I think by creating a separate USD file for each variant selection, I think that can
No, no,
also be
you
the
have to
answer.
set. You have to. How can you set the current variant in a variant set?
Mm-hmm.
How can you set the current variant?
Yeah, set variant selection. Correct. 10.
Okay,
We have
that's
done
it.
10.
Again, 80% strike.
But we need
It would have
85% to pass, bro.
it would have been 90, but somebody was too smart.
Oh, okay.
Well done.
All right.